Hello everyone and welcome to the channel. I'm Emmanuel, I'm an airline pilot, and welcome to my tutorial for the Fokker 70 and Fokker 100. Today we are going to fly the Fokker 70 from Amsterdam to Geneva on a quick 1 hour and 10-minute flight. In this tutorial I will take you over all the standard procedures that you need to fly the airplane professionally from A to B based on the tutorial that's included in the 200-page manual that comes with the products. We are going to make use of the full checklists that are included in the airplane so that you can fly the airplane one-to-one the way that JustFlight intended you to fly it. Now let's go ahead and get started with a quick look into our flight plan. And for that, please follow me inside of our Fokker. Now we are going to start with the very basics over here. When you go into the electronic flight pack and onto the OFP page, you will be asked your SimBrief account, and once you have logged in, you are given access to your flight plan. Now, the flight plan page consists of 3 pages, which are a summary where you get the most important things that you need for the programming of your flight management system. Then you can get a weather page over here, which you can refresh. So by default, it loads with the SimBrief data. If you do hit refresh, then you can see it will update the weather to the live weather. And finally, you have the output page where you can access your SimBrief flight plan. I've chosen the Lido format for this one because it seems to be the most popular one that you will get with flight simmers. However, you can use whichever format you like. Now, on this page, a couple of basic things that we want to have a look at. The first one is always the weather, and for that you could use the meta page. However, that will only give you your current weather, or you could go forward on the actual flight plan and search for that. And that is my recommended procedure, because the flight plan will not just include the current weather as in the meta, but it will also include the forecast weather as in the TAF. And that is really what matters more. Now, looking into the TAF, couple of things that we want to take into account for taking extra fuel. We are going to start with good weather. So good weather, something like we got over here, variable 2, cav, temperature up to 36 degrees. Now, anything that might pose a threat to our arrival, for example, strong gusts, thunderstorms, CBs, that kind of stuff, should be taken into account from the time that it is forecast minus 1 hour to the time that it is forecast plus 1 hour. And that span has to be around your estimated arrival time. Now, if we look into our flight plan over here, we can see our estimated arrival time is 0620, and it might take us about 10 minutes longer to get there, so 0630. So that means we would want to look at the weather from 0530 to 0730 in order to determine how much fuel we want to take. So therefore, that Prop 30 tempo weather from 1500 to 2000 is not applicable as it is beyond 0730. So for our arrival time, only that weather on the top over here counts. So that's variable 2, cav 36 degrees. So beautiful weather conditions. The same also applies to the alternate, with the caveat that we of course need to take the flight time to the alternate into consideration. And then again, you're looking at the weather plus minus 1 hour. So you can see that Lyon has fantastic weather and is going to remain fantastic as well. Therefore, we can decide whether we want to take extra fuel or not. Now, how much extra fuel you want to take is a little bit dependent on your airline's operational philosophy. Like, many airlines will say, okay, with thunderstorms, maybe take fuel for 15 minutes in a holding, because that is kind of the standard time that you would take for a CB to move through the airport, or for a thunderstorm cell to move through the airport and clear it again. And then maybe, another 10 minutes for the delay that you might get, because other aircraft will, of course, be holding and then approaching as well. So with weather like that, you may consider something in the region of about half an hour extra for the arrival time. There may be other airlines who say, okay, we do generally not really care about diversions. So even with that kind of weather, if the weather at the destination is bad, but the weather at the alternate is fantastic, like it may be in today's afternoon, then we are simply not going to take any extra fuel at all. And if we arrive at the destination, it's bad, we don't even attempt an approach, we just divert to the alternate straight away. So there's different philosophies on this. All of them are valid. You simply have to have a plan. Now, how much extra fuel do you need for a certain time? When we're talking about extra fuel, we're basically always thinking in terms of time. So I want to take half an hour extra. Okay, then I look at my flight plan, and down here we can see half an hour extra equals around about 900 kilograms of fuel. Therefore, if I want to take 10 minutes extra, 900 divided by 3, that's about 300 kilos of fuel. So that way you can easily deduct how much fuel you need, even if you're not too familiar with the aircraft type just yet, simply from looking at the planned fuel section in your flight plan. Because you always have those 30 minutes or another set amount of time, and then you can make any deductions from that. You could also use your contingency, for example. We got 5 minutes over here, and that is 164. So again, if I wanted 10 minutes, that times 2, roughly 300 kilos. So that's how you can determine the extra fuel that you want to take. Now, we are determined that today we've got fantastic weather. We do not need extra fuel for any of those purposes. We might need extra fuel in case of a go-around, since this is a tutorial new to the airplane and so on. So because of possible explanations, maybe a holding and all that kind of stuff, we may want to take a little bit of extra fuel, and for this reason I'm going to load 15 minutes on top, which equals approximately 450 kilos. Now, if we have a look into the fuel section down here, they want us to take 4.7, so let's make that 5.1, so 5,100 kilos of fuel. Now, once we have decided on the fuel quantity that we want to take, we can load this in the electronic flight bag. So for the loading, and that leads us right into the entire payload, we can go into the aircraft app, and as soon as an operational flight plan has been imported, once you enter the aircraft app, you will be asked if you want to import your payload from SimBrief. We can do this right down here, and this will preset the standard SimBrief figures. Now, you have several options there. You can go for instant refueling. You can take a certain defined time, which in the Fokker isn't too important, but if you've got a larger airplane like a wide-body aircraft that can take an hour to refuel, that may be something. Or you can use the realistic option, which is really the option that we are going to go for today's video. Before you click start refueling, make sure that you have set the appropriate amount of fuel that you want to take, and you can see that the flashing values over here are the values that have been imported from SimBrief. Now, this is always going to be the exact SimBrief minimum fuel. So if you want to use, for example, your APU, you might want to take a bit more than that, so that you are going to have at least the minimum when you go off block. Today we said we wanted 5,100 kilos, so that's going to be 2,550 for each tank, which we can simply type over here. And then also type over here, so that we got the distribution per fuel tank like that. And with the correct amount entered, we can hit start refueling, and then the refueling is going to be in progress. You will see a counter over here, and once electrical power is applied to the aircraft, you will also see the fuel gauge increase over here. Now, next up is going to be the payload, and that depends a little bit on the option you have selected. So you got the payload menu down here. You can see you can either do an instant boarding, you can choose whether you want to use the jetway or the stairs, or if you go up here into the settings, you will find an option for GSX handling. If that option is ticked, then the boarding option is basically going to be using GSX. So then you can simply select the boarding option over here in GSX, and that is going to start your boarding completely automatically. So we're going to come back to that later on. The number of passengers is decided down here, the cargo is decided up here, and all of that together is going to give you your zero fuel weight, which then gives you the zero fuel weight plus total fuel equals the complete gross weight of the aircraft down here. You also have the option to select a ground power unit up here, and we are absolutely going to do that for the purpose of today's flight. Note that if a jetway is connected to the aircraft, you can also get electrical power from that without getting a ground power unit, which you can see is spawning in front of the aircraft over here. So you do have that option available right within your aircraft. Now, that is our general aircraft setup. With that done, let's go ahead and get right into the safety inspection and the power up of our Fokker. For that, we are basically following the procedures provided by JustFlight, and while you do have a full tutorial that explains every single step inside the product manual, you do have the basic checklists over here, and those are very complete checklists. They seem to have followed the philosophy of giving you a great overview of all items. Like, you don't just have the single most important ones, but you actually have pretty much all items on the checklists down here. So the way this is done in an airliner is that you do the checklist from memory and then later on confirm it with the follow-up checklist down here. But seeing how complete the checklists are in the JustFlight aircraft, you can basically kind of use this to move along if you do not know exactly what to use as well. So let's go ahead and get started with the power-up checklist. For that, the first point is circuit breakers, and for that we check all the circuit breakers over here to be completely pushed in. The easiest way to check a circuit breaker is just by going slightly next to the panel, because if one was popped out, you would easily see it over here. Now, with that checked, we are going to check the fuel levers to be both in the down position and the landing gear selector to be in the down position as well. With that, our airplane is safe to be powered up. So let's move to the overhead panel, turn on the battery, select voltage over here, and then rotate the selector to the battery icon so that we can check over here and over here that our batteries number 1 and 2 have a minimum of 24 volts. With that checked, we can turn on the external power if one is available, and then consider whether we want to start the APU or not. Now, today we do have external power available, but since it is pretty warm outside and since the sun is shining right onto our aircraft, therefore heating it up even further, we want to start the APU straight away. So in order to start the APU, we first of all run the APU fire test, which works once the battery is powered. For that, here on the test panel, press and hold the APU fire button and check the APU fire light over here on the APU fire panel. Now, once the APU fire test is complete, we check that the APU fire switch is in the guarded position, and then we can move down to the APU selector on the forward overhead panel and rotate that into the start position. Now you can see 3 selector switch, off on start. In order to rotate it into start, you have to pull it up, and then you can put it into the start position and then drop it in. Then it drops back onto the on position, and that initiates the APU starting sequence. Once the APU is available, you will see the avail light over here, and APU bleed is automatically going to be applied to the cabin as long as the APU bleed button is pushed in, which it should basically always be by default. Now, from there on, our APU is starting and air conditioning is going to be applied automatically. We do have AC power available, so the next step is to turn on our IRSs. Now, the IRSs, again, located over here, are rather easy. You simply rotate them to nav, but to get through a line into nav, you have to pull them out and then drop them back in. And you can do that by simply clicking into the middle of the switch. and that puts the IRS selectors into the nav position. Now, from there, we move down to the forward overhead panel and arm our emergency lights. And finally, we make sure the exterior lights are set, so as soon as power is applied to the aircraft, we want the nav lights and the logo lights on, which we can do through that switch over here. The remainder of the switches remains off for the time being. And with that, our power-up procedure is complete. And we can go right into the pre-flight procedure. Now, the first thing, emergency equipment on board is something that you can't really reasonably check in the sim, because obviously we could go over the facts. Do we have the disruptive passenger silencing device on board, aka the Crash X? Do we have whatever other emergency equipment is required? But since that is a fixed part of the model, I don't regard that as too important. Next is going to be the oxygen, and for the oxygen we first of all check that the passenger oxygen switch is in the guarded position, and then we can move right down. We got the oxygen mask on the captain's panel, where we are going to test the panel. Now, next up, we would press the emergency switch down here, and that entire thing should give us a continuous test then. Now, in the preview version that I'm using to record this tutorial, that's not 100% modeled just yet. We'll also do the same on the first officer's side down here, and that is our oxygen test. From there, we turn on our multifunction displays, and those are good old CRT displays. So on a longer turnaround, you would also keep them dimmed, but we do want to turn them on. For the purpose of the video, we are going to turn them on completely. So we got the PFD and ND located up here. Then we got our MFDs located down here. Then we got the co-pilot's displays located over here and over here. And finally, we have our FMCs, which we can turn up with the brightness selectors over here and over here. From there, we are going to go on into the FMCs straight away to initiate the alignment sequence of the INS. Now, the IRS will take a little while. You can check how long by looking at the IRS panel and rotating the selector all the way to the right to the heading and status page. You can see over here is going to take 9 minutes for the alignment. Now, in order for the alignment to process properly, we need to give the system its initial position, and we can do that down here in the FMC. So let's quickly go over how to do that. First of all, we check that we got the correct aircraft. So a Fokker 28 Mark 70, that's the airplane that we're in. Then our engine type is correct, and the nav database is up to date. From there we move down to the init page, and now there's 2 ways how you can do this. We're going to take a more extensive look when we start programming the rest of the FMC. For now, we simply need to enter the departure and arrival airports, and you can either do this by entering the airports separately. So for example, Echo Hotel Alpha Mike for the departure, / Lima Sierra Golf Golf for the arrival, or you enter that thing without the slash as your company route name, and then you put that on the left over here. Provided that a SimBrief account is available in the electronic flight bag, this is automatically going to download your SimBrief route into the FMC as a company route. Now, today we will do it the manual way to show you how to program a route manually. So let's just put that over here. And now you can see it calls up the company route page. Now we don't have any company route stored at the moment, so we can simply click return. Now you can see this automatically inserts the departure airport coordinates down here. Now, technically speaking, you do want to change those to your gate coordinates. Many airports are going to have a sign with the coordinates up there. If not, then you can usually find a chart with your coordinates in your airport charts. So if we go down here, airport chart, departure, search, under taxi, you will usually find something like departure airport stance and coordinates. So that would be this one over here. Then you simply search where you are, and then you enter that exact coordinate down here. Using the up and down arrows, you can scroll around like that and enter exactly where you are. Now, once that position is entered, today I'm going to keep it simple, I'm going to use the airport position. Hit the Align IRS prompt down here, and now that that is in progress, the IRS alignment is commencing normally. The INS can conduct its position self-checks using the longitude provided, and now we basically have a normal alignment. Now once that is done, we are going to continue right back onto the test panel, and that's located again up here. There are several tests that we want to do. The first one is the engine fire test. So press and hold the switch onto the number 1 position. You can see we got the engine fire light illuminate. Then moving down onto our displays, we got the engine fire 1 procedure showing over there. And we also have the engine start lever illuminate on the associated side as well. Now let's go ahead and repeat the same thing for engine number 2. Again, we got that. Now this one, we need to clear manually in order for the second procedure to show. I'm going to show you that in a moment. And down here we have the engine start lever illuminate as well. Now let's release that switch. Now how do you clear a procedure from the display? Basically, just gonna click through it down here and take it all off. And like that, we've got it cleared now. So, that's the engine fire tests. Run the APU fire test if you haven't started the APU earlier already. Then we got the smoke test. We can see we got the 2 smoke lights illuminate up there. Then we got the annunciator test. Press that, and then we're checking for all the lights in the switch buttons and everywhere to illuminate. From there, we are going to move down to the GPWS test. And you want to press this just for a very short time. The reason you want to do this for a short time is because if you press it for a longer time, it's going to run a very extensive several minute test. And yeah, it's just loud, you don't want that. Finally, we are going to run the warning system tests, where the airplane once again is going to run brief checks of all the warning systems. And we confirm that this test is in progress by looking down here, where you can see warning systems in test. Now, that thing is going to run automatically. If anything happens, the plane will alert you to it. So our next step is to turn on the voice recorder so that all the pre-flight procedures are recorded. And when that thing has been turned on, we're also briefly going to press the test button on the CVR panel over here and observe that audio is getting recorded. Like that. Now with that done, we check that all the aircraft documents are on board, and with that, we have finished our Powerup and our pre-flight procedures, again pretty much according to what we got down here on the procedures as well. Now, with all of our pre-flight procedures completed, we can go right into the standard pre-flight setup. So let's go ahead and do that. Now, first thing, as always, is going to get our departure weather. There's several ways of doing that. You could either go through the OFP page in the electronic flight bag, or what I would recommend at this point is to go into the Performance app, because we do want to know, can we even depart from this airport? So let's go to Performance and have a look at the calculator we got available down here. So you got a takeoff and a landing page. Now, we obviously care for the takeoff right now. Our departure ICAO is Amsterdam, so let's enter Echo Hotel Alpha Mike. Then we can select the runway over here, and we are departing from the Polderbahn today. Runway length, I would typically set this to meters, because we're not in the United States. And then you can use the takeoff shift on the top right in order to calculate any intersection takeoff. Now, today we do not want to do any intersection, but if we wanted to, here's how you can do it. So for most airports, you will find not just a standard airport chart like this one, but you would also find an airport information chart. Now, let me just go over an example of how to calculate an intersection departure over here. So There's runway 36 left, our departure runway. Let's say that we don't want to taxi down here, or that we want to consider the opportunity of departing from here in case that intersection down here is blocked by any aircraft. Now, we got 36 left. Let's go into the airport and departure minimum chart. Now over here we can see loads of different runways on the left hand side. We're looking for 36 left down here. And then there is this little chart, takeoff run available. So, from the runway head on 36 left there's 3,800 meters. From Victor 3, which is what we have just looked at, there is 3,247 meters. We take that minus that, so we're looking at roughly 553 meters of shortening. And now we can go into the performance app and takeoff shift reduce available distance by 553 meters, and that way we are now basically shortening the runway to what is available right from the departures intersection, and that way we have calculated an intersection takeoff. Now going down a little bit further, we got the runway slope, which is automatically filled when the runway is selected. Then we got the flap setting, and that is something interesting on the Fokker 70 and Fokker 100. So if you leave this in auto, the plane is probably going to calculate a flaps 0 takeoff most of the time. Now, contrary to the vast majority of other airliners, the Fokker 70 and Fokker 100 are certified for a complete flaps up takeoff. Now, we could talk at length for the reason why that is. The most important point here, if we have a look into our aircraft's wing, is that this airplane is not fitted with any slats. It's pretty much only fitted with flaps. Now, what's the difference between the two? Flaps basically control the pitch of your airplane as well as the drag of your airplane, while also providing a little bit of extra lift due to the increased camber of the wing. So that's basically the way that the wing is shaped. Like you can have a wing like that, or you can have a wing like that. Now, if you have the flaps down, you have a wing that looks more like that, so an increased camber, and therefore the airflow over the wing accelerates a little bit, providing a little bit of extra lift. But the flaps, so the devices at the end of the wing, mostly provide increased drag and only a little bit of increased lift. Compared to that, slats usually provide a very small gap in between the slat and the wing, through which air is forced that is then hugely accelerated due to the Bernoulli effect, and therefore rapidly increase the lift of your wing. So what I'm saying with this is an airplane that does not have slats is only going to be able to increase its lift marginally. On a short runway this may matter, but on a typical to a long runway this basically doesn't matter at all. Therefore, using flaps for your takeoff would only provide a very marginal effect, which may matter on a short runway, but usually on this airplane you are going to take off with the flaps completely up. So, if you keep this in auto, most of the time on a long runway you are going to get a complete flaps up takeoff. So that's an interesting little fact about the Fokker. Now from there, any skid is operative. Weather, for that I would recommend to press the import live weather button, and that is going to update your weather with the most current live weather. So today we can see that 040 at 7, no significant clouds, 21 degrees, QNH 1019, and that's automatically filled down here. Next up, the runway surface is dry today, anti-ice. Now, when is anti-ice used? Basically when the outside temperature is plus 10 degrees or less, and there is visible moisture. Visible moisture could be fog with a visibility of 1,600 meters or less, clouds at a very low level, basically below the thrust reduction altitude, usually 1,000 above the airport, or any form of precipitation, or any form of contamination on the surfaces, like for example large deposits of water, snow, slush, ice, and so on. So all of those cases, 10 degrees or less and visible moisture, you would depart with the anti-ice on. Next up we need the takeoff weight, and for that you could have a look down here into the aircraft menu, but always remember that if you are using live boarding, then the current gross weight shown to you down here may not equal what you've planned. So we've planned 29.2 as our zero fuel weight plus our 5.1 tons, so that's 34.3 roughly. So let's use those 34.3 for our performance calculation. Enter that down here, so 34,300, like that. Once everything is entered, we're going to hit calculate, and now we're going to get a certain set of data. Here's our takeoff speeds, 124, 124, 132. Now our flap retraction speed, as you can see, is not applicable because, as I predicted, it has calculated a flaps up takeoff. Here's our flex temperature, our trim setting, the transition altitude, then we've got the thrust reduction and acceleration. Now this is not calculated individually per airport as far as I'm aware. So for this, kinda still have to check manually which noise abatement procedure applies to the airport that you're currently departing from, and then use that particular noise abatement procedure. Then you've got the headwind, tailwind, and crosswind. You can see we got 6 knot headwind, 0 knot tailwind, and 4 knot crosswind with the current weather on this departure runway. Lastly, what we got down here is the distances at which we are going to reach the particular speeds on our runway. We can see hugely long runway today. It's absolutely nothing to worry about. V2 is going to be reached by 1,363 meters. Now, in order to be legal to take off, you need to multiply that depending on the runway condition. Let's not make it too complicated. Multiply it with 1.25, and then you got your safety margin. So as we can see, we are absolutely legal to take off today. And that is what we are calculating for our preliminary performance setup down here. As you can see, not all that complicated. JustFlight has provided us with a fantastic tool for doing these types of calculations over here. And with that, let's go ahead and go into the normal pre-flight procedure. So for this, we are going to go over the entire panel scan. Try to remember the scan flow pattern, and then it's going to be pretty easy in the future to repeat this and not miss anything. Starting on the overhead, top left, then we're going to go all the way down on the left side, then we do the same in the middle, then we do the same on the middle right, and then we do the same on the right hand side, until we are completely finished with the overhead. Then we go over the EFIS control panels, over the main panel, and then we are going to go down on the pedestal. Again, that thing is parted in 3 ways. Number 1, number 2, and number 3. So, let's go ahead and get started. Up here on the avionics panel, we make sure all the lights are out, except for the voice recorder ground control switch. On the flight augmentation panel, all the lights are out. On the hydraulic panel, all the lights are out, and then we are moving down here, and over here we can test the calls, so that it calls all the departments in the aircraft. At this point, let me also show you something that JustFlight does enable you to do. So you cannot just call the cabin can call you as well, and there is a call button located right up here. So you can either call the back of the aircraft, you can turn on the public announcement system and then make a PA through the handset, or you can call the pilot like this. You can see when a call is done, you will see the blue call light illuminate on the top of the panel over here. You can reset that with a button at the bottom if any of those are illuminated. Now the wiper is switched off, and provided that our refueling is complete, and we can see that it is now, we can turn the fasten seatbelt sign on this panel as well. Then we're moving on to this second part of the overhead. Again, the CVR test is already done, the tests have already all commenced, the engine fire switch is pushed in, On the electrical panel, we ensure the battery is on, no lights are illuminated except for the external power if it is in use. The anti-ice panel is all switched off, and the external lights only have the nav and logo lights on, and that is it. Moving down, or rather moving up, to the third panel, the IRS mode selectors are in the nav position, the cargo fire squibs are both guarded, passenger oxygen switch is guarded, engine 2 fire switch is pushed in, the center tank fuel pumps are switched off, the rest are all lights out. The engine start panel is set to normal ignition and the engine start light is out. And on the pressurization panel we are going to set the departure field elevation. For Amsterdam that's minus 13 feet, so just basically have it at 0. And on the cabin pressurization panel we want to see 0 differential pressure, and the cabin altitude gauge should show the airfield elevation, so basically 0 today. Moving on to the right hand side, the APU fire switch is guarded, then all of the air conditioning is pushed in, so no lights illuminated, and on the propede panel the pitot heats are off, and the window heats can already be switched on at this point. Moving further down, the wipers are off, the APU is set as needed, and the emergency lights are armed. With that, we can move down to our EFIS control panel, and for that, let's have a quick look at the functions of the buttons we got over here. First of all, a little trick. By default, the yoke may be a little bit too far forward. Can solve that by turning the control lock off, then moving the control column into the neutral position, and then turning it back on again. Some pilots do like to lock it in the forward position when leaving the aircraft, because it's easier to get in and out of your seat with that position. But it obstructs your view of the nav display, so that way you can move the control column back into the neutral position. Alright, so what functionality do we have on the EFIS control panel? First of all, we got the mode selector. We got the plan mode, where it focuses on a certain waypoint from the FMS, more on that later. Then we got the map mode, which is your standard nav display selection. You got the ARC mode, which is VOR or ILS. And whether it shows VOR or ILS data is controlled through the approach VOR switch over here. So when either ARC or ROSE mode is selected, this switch is automatically going to turn onto VOR, but if you press it, then you can switch it onto the ILS. So approach equals ILS and VOR equals VOR. By default, we do want to take the map mode. Then we've got the range selector, and that has a couple of special modes that you haven't seen in other airliners yet. First of all, you got the B modes, and B basically shows you what's behind you as well. So you got 15 or 30 miles, respectively what's behind you, and then you got the standard setting of 15, 30, 60, 120 and 240 miles. So we want to use the standard 15 setting for most departures, as it is going to show us the most important data for our flight. Now, next to that, we do have our minimum selector, where you can either set a certain flight path angle, you can set an MDA or a decision height. For the departure, we basically want to leave this at 0. Then we got the brightness selectors for the PFD and the ND. Moving further down, we got different modes for our maps, and by default we do want to take constraints, airport and traffic. Then we got the altimeter switch, and this can be toggled between QNH, where you got your QNH in millibars. A millibar is basically equal to a hectopascal, or you can select standard on this switch, like that. Now, you do not have a possibility to switch around between millibars and inches, or respectively hectopascal and inches. A Fokker that's configured for the United States would be in imperial units, and you can do that up here on the aircraft screen. Going into the options, down here you can choose between hectopascals and inches. So if you're flying in the United States or North America, then do select inches over here. If you're anywhere else in the world, then you are going to have millibars over here. Now, in order to change this, just select the right down here. So let's go ahead and have a look into what the current weather is. And we can see we got a QNH of 1019. So you can select that right down here now. 1019, 1019, and 1019. Again, you do have an option to either synchronize the different settings. So that's again on the aircraft menu, options, and down here you have synchronize altimeters. When turned on, then all three altimeters are going to synchronize on the same setting. When turned off, you have to control them manually. And finally, you have the weather radar brightness. Now, this is quite different to an Airbus. In an Airbus, you would always turn that on. In the Fokker, turning on the brightness is going to turn on the weather radar itself. So ensure that it is off at this point. The easiest way to tell is by looking down at the nav display. If we do turn this on, you can see number one, we're getting a warning on our EFIS, weather radar not off. And number two, you get the weather radar indication up here and down here. So make sure that this is turned off at the gate. Moving further onto the autoflight panel, we can either set this up now or we can set this up later, depending on whether we already know all the figures that we are going to use over here. For example, if you're flying out of your home base, you know what you're gonna dial in anyway, then you can just do that now. If you are flying at an airport where you may not be completely familiar with the procedures, do delay it to later when we are setting up the FMC. For now, I'm just going to switch on the flight director switches over there, and that's gonna be it. We'll do the entire rest later. On your first officer's side, they would of course set this themselves in a real multi-crew cockpit. Since we don't have that, let's just make sure we got a standard 15-mile range, constraints, airport, and traffic, and the weather radars off on his side as well. Okay, from there we can move further down onto the main panel. Starting on the left side there, we got a couple of options that you could transfer, for example, between the source of information from your side, and then you can also select whether you want to see the ADFs 1 or 2 on your main panel. So you could switch those on over here. We don't need any of those radios for our departure today, so we're going to leave them off. The elapsed timer is reset, so you can do that down here. And then we're moving further onto the right hand side, where we are going to align the standby attitude indicator. We can leave the standby engine displays off for the time being. The QNH is set, and the auto brake is then off. You cannot set this until your engines are started, so off for now. Landing gear lever is down and the override button is out. On the backup caution panel, you can basically leave everything off. If you press that button in the middle, then you are going to get your backup shown over here, but as you can see, that's just a backup, so do leave it off as long as your EFIS is working and your cautions are shown down here. Alright, further on the right hand side, again, if you are using separate altimeters, make sure that the QNH is set down there as well. Now, the brake temperature gauges down here are pretty important if you do a turnaround, because you want to make sure that your brakes are cool for takeoff. So if you are doing a turnaround and the brake temperatures are high, then it is recommended to place the chocks around your aircraft and then release the park and brake down here, which improves the cooling of your aircraft's brakes. Moving down onto the pedestal, we got the light controls down here. Now these are some pretty interesting controls in the aircraft, because they're a little different from your conventional aircraft. So what do we have over here? First of all, we got the overhead panel lights. Then we got the backlighting of our panels located in the top or the inner part of those light switches over here. Now what do I mean with that? Well, let's have a look. Right now the lights are off. If we turn them on, this is what happens. Now, we do basically want to turn those three on, because it makes it a lot easier to read the numbers that we got over there. And then the outer parts of those panels control the floodlight for the respective part of the panel. So, for example, if we switch this into night real quick, I can show you that over here. So you do have your main panel left, then we got the main panel right, we got the autoflight panel over here, and then we do have a dome light over here which illuminates the entire flight deck. So That's what we got. And then you have a storm light. Turning that on is basically going to turn everything to fully bright. Then you got the backlighting of the panel like this, and like that for the overhead. And that's your cockpit light controls in the Fokker. Now let's go back to real time over here, and then we can also turn those back off again. The only ones that you really need during daylight are the backlights, so the inner ones that you got over here. Alright, then you got the brightness of your switch lights. By default, those are set to bright. If you do switch them to low, you can see it becomes rather difficult to read those, especially with things like the landing gear lights down there, so you basically want to keep those on bright like all the time. Moving further down, we got our audio control panel. Now, let's talk about a couple different settings that you can make down there. First of all, the top controls the nav radios. You got a speaker down here, and then the bottom controls the individual radios that you're listening and transmitting on. So by default, you can see VHF1 transmitter is selected, and we are listening to that as well. You can control all the volume by that setting. So basically, we always want to listen to VHF1 and VHF2. And on the top, you can control which one you're transmitting on, which by default is going to be VHF1. On the right hand side, this one allows you to transmit on the public address system, and this one allows you to talk to the cabin crew. And you can hear the volume of the cabin crew through that switch. Basically, we do want to be able to talk to the cabin crew as well, so you could turn this one on, or you could leave that off, and whenever the cabin crew calls you, which is going to happen a couple of times throughout the flight, you can turn that on as needed. Now from there, we are moving further down. The anti-skate switch is guarded on. The flight deck door is going to be unlocked at this time, so that's what we see down there. The parking brake is set, and then we're moving down to the radios where we can set our frequencies as needed. Now the Fokker has an interesting system here. You can see we can select the frequency both on the left and the right hand side, and then we got a switch in the middle which basically controls which of those frequencies is active. So like that, now we are transmitting on that side, now we're transmitting on that side, both within the VHF1 radio. So you can change the active frequency over there. Now moving further down, we got our ADF. Since we don't need an NDB on today's flight, we don't need to set anything there. And then we got the weather radar controls. We want to make sure the tilt is around about at 5 degrees up for your takeoff, since that will roughly equal your flight path angle. Then the mode selector is going to be weather plus turbulence for most of the flight. And then down here we got VOR DME tuner. Now that thing is dashed out. If you want to tune a VOR DME, you can do that on the progress page of the FMC. So down here you can see there's a radio and there's a radio, and that's where you can tune your radios by either typing the ident or the frequency into the radio. More on that later. Next up we got the thrust rating panel, and on that one we can either control our MFDs or we can control our engine thrust rating over here. Now we are going to get back to that later on once we have received our load sheet. For now, just know that this exists. Next up is the transponder, and there's a couple of settings that we want to make over here. While we're doing pre-flight on the ground, we do of course want to have the transponder in the standby mode. The mode selector is going to be either on the number 1 side if you are the pilot flying, or the number 2 side if your first officer is pilot flying. Your TCAS mode selector should be on above, so that it shows you more traffic that is higher above you, and then our squawk should be 2000 while we're at the gate, before we have received the IFR clearance. Now, moving on from here, we also gotta set our flight ID. We can do this through the ATC/ID switch over here. Press that switch, then click and hold the clear button, and now we can enter our flight ID down here. Now, what is the flight ID? For those of you flying on an online network, you connect to the network using a specific call sign. In the real world, your transponder has to transmit that call sign to the ATC systems. So that's basically the same thing as connecting to an online network. So in here we need to enter our call sign so that ATC is going to see us correctly on their radar screens. So this basically is the call sign that we are going to use for our flight. Now for that, let's have a very quick look into our flight plan. And then we can see that our call sign, and that is not the flight number, it is the call sign, very important difference there, is KLM 27 Echo for today's flight. So how do we enter that? Well, the older guys among you are going to remember, if you want to type a K, then you're going to hit that 4 button, and you press it several times until you got the K. Now if you want to type the L behind that, you wait for a short time, and then you press that thing 4 times, now we got the L. For the N, we can press the 5 button twice, so here's KLM. Now we got 27 Echo, so let's press 2, 7, and then we press the 2 key 3 times, so that we get the Echo. And that's how you enter the call sign over there. When you're finished, just click the ATC Flight ID button again, after hitting enter, so that it returns you to your squawk page. And this is how you enter your call sign down in the transponder. Again, very important setting. Lastly, we do have the ILS receiver that we can tune down there, but you could set up an ILS frequency for an immediate return over here. We're not going to do that today. And then we got our VHF2 radio, where we are going to set the emergency frequency 121.5 active, and the standby frequency on this one would normally be used to set something like a company frequency or the departure ATIS. From there, we are checking that the stick pusher switch is in. We could set our second NDB down here, and if an HF radio would be required, that's nowadays still in use in some cases in Africa, then you could set your HF frequency over there. Again, if you want to enter a frequency for the second VOR, you could do that down here. Finally, moving down to the trims, we check that both the rudder trim is in the middle, so the line over there is aligned with the line over there, and the same also applies to the aileron trim over there. Lastly, we have our flight control lock, which is going to be on at this point, and then on this side we've got the alternate landing gear control, which is in the down position. And that completes our flight deck setup. So from here we can go straight into the avionics setup. Alright, so avionics setup, aka FMC setup. Then let's go ahead and get started with the FMC setup. So unfortunately, I couldn't find a way to move the electronic flight back down here, so I am going to use the default 2D flight plan for this. Now, as mentioned at the beginning of the tutorial, you can load a route 2 ways. You can either enter your departure and arrival airport pair on the top right by typing departure/arrival, so in this case Amsterdam/Geneva. When you do that, it is going to pull up the stored routes for your flight plan, but assuming that you do not have a stored route, which is really how most operators of the Fokker would work, then you simply return back out of it and enter the route manually, which is what we are doing today. If you're feeling lazy, and do note that most Fokkers do not have any data link capability. However, if you do feel like it, you can uplink your SimBrief flight plan by typing the company route name, which is departure arrival, so Amsterdam, Geneva, like that, and entering that on the company route field over here. As long as a SimBrief identifier is in your electronic flight bag down here, that is going to automatically uplink your route from SimBrief for the lazy guys among you. Today we do that manually, so let's go ahead and get right into it. Okay. So, let's get started. Now, departure and arrival airport are in there. Next up is going to be the alternate, which today is Lyon. So, If you don't know the code for that, you can just scroll down, Lima Fox Lima Lima, like this. And here we go. Now the Align IRS prompt should no longer be showing. If you forgot to press it earlier though, be sure to press Align IRS. Next up is the cost index, which again we get from the flight plan. Today that is cost index 20, and the cruise flight level 350. Normally needs manual entry, I'm not quite sure why that's here already, but just be aware, we entered that. Next up is going to be the temperature in cruise flight, and you may either have that in the flight plan anywhere up here, or you would often find it in the nav log. So you have a nav log over here, and we can see the OHE, so the temperature shown up there. So let's find a waypoint, top of climb minus 50. Normally we take the temperature one past the top of climb, because Lido has some problems calculating top of climb temperatures in the real world. So that's going to be minus 50 degrees. Let's enter that. Next up we need the cruise wind, which is your average wind. Again, depending on the flight plan layout, that may be found in different places. For us today, that's over here, 159 at 3. Like this. Alright, and here it is. Now from there, let's move on into the flight plan page. Now this is quite similar to what you're used to from your standard Airbus. That's because both Airbus and Fokker are buying third-party avionics, and yeah, it is the same system. So, how do we enter a flight plan over there? Now, let's go ahead and start with our route. We are departing on Amsterdam 36 left on the low pick for Victor departure. So we click on the left button next to our departure airport, and then we can select the standard instrument departure up here. Okay, so let's scroll until we find our departure Romeo in the list. Here it is, 36 left. Like that, and then again we're gonna scroll until we find our departure routing. Low pick for Victor, here it is, and we select that. If a transition is available, that would show over here, and you can select it. If none is needed, and we don't need one today, then simply press the insert button. Next we got an airway, which is November 852 to Lima November Oscar VOR. So let's scroll down to low pick, press the button on the left of it, and then we have the airway menu over here, which we can select. Over here we can enter the airway, November 852, and then the endpoint, which is Lima November Oscar. If that first airway is followed by a second one, then you can simply enter the second airway down here, and the intersection between the two would be automatically determined. However, since many airways have multiple points where they are crossing, you always need to check that the correct intersection is automatically determined. Since we are going to fly on a direct after Lima November Oscar, we are simply going to enter that waypoint manually, and once we're done on the airway page, remember you cannot enter directs over here, we are going to press insert. Now you can see that from low pick, all the waypoints on November 852 have been added all the way to Lima November Oscar. Next up we are going to enter the direct SUTAL. For that we simply enter SUTAL, like that, and put it right beneath Lima November Oscar. Next is going to be Golf Tango Quebec. Then we fly to Pogol. Then we fly to Lazard. Then we fly to Morocco. And if you need to enter more, you can always scroll, but we got an airway again, Zulu 24 Akito. So again, lateral reversion from Morocco, airway, Zulu 24 towards Akito. Like that, insert, and that's it. If you need to delete anything, simply press the clear button, and then you can remove whatever you may want to remove. Now, our arrival will be the Akito 3 Romeo onto Geneva's runway 22. So let's select the destination. Then we can click the star button, and that leads us onto the approach selection. So runway 22 is active. Let's select the ILS approach, and then we got the Akito 3 Romeo arrival, which we can select up here. No transition for us today, so that's completely fine. And with the correct approaches selected, let's press the insert button. Now, if an approach transition, remember there's two types of transitions. There are transitions from the airway onto the star that you will see mostly in North America, and then there is transitions from the star onto the approach, like we got over here. Then that shows up after you pressed insert. So, do we want to take the safer transition? Yes, we do. So let's hit that button. And now you can see all of that is entered. So let's go ahead and cross-check that our departure is actually correct. Well, this doesn't happen 100% of the time, but in some very rare cases, and I'm flying for many years now, I did find maybe 3 or 4 database errors in that time. So the chances are incredibly low. However, we always want to cross-check. So let's go over to the chart button. Let's find our SID. Now this was the low pick for Victor. So let's go ahead and find low pick for Victor. Here it is. And pin that one using the star. And here's our departure. So, low pick for Victor, straight ahead to Alpha Mike 084, maximum 220 knots, right turn, waypoint 045. Let's go ahead and cross-check this, and the way we do this is by going onto the plan mode for our nav display. And now we can see we got Alpha Mike 084, which is an overfly waypoint as marked by that triangle on the right-hand side over there. And by the circle around the waypoint on our chart. Now, we overfly that and then make a right-hand turn onto a 167 course, inbound to waypoint 045. You can see in here, we got a course 167, inbound to waypoint 045. And up here, we can see we overfly this, then we got the right-hand turn marked by the arrow over there, and then we got Alpha Mike 045 and the 220 knot limit over there. Now, I'm using a preview version of the airplane to record this tutorial, and you can see normally you should have your constraints over here as well. The preview version has a little bug, but you can always go to the vertical revision page to see the exact constraint as well. The release version should have that bug fixed. If not, they are gonna fix it post-release. But that's how you are going to cross-check the entire SID. So next we're going to proceed via Alpha Mike 036 and then towards Ogina. And again, by scrolling through the flight plan with the arrow pages, we can scroll through the flight plan on the ND, provided that we're in plan mode down there. And that way we are now going to go over the entire SID. So from Ogina we are going to proceed towards low pick. And we can see we got Ogina and then we got low pick. Now, if any altitude constraint would apply, those should also be checked down here on the nav display. Remember, constraints need to be selected for that, and down here on the flight plan page. However, that constraint here only applies for VFR flights without ATC clearance, so that doesn't matter for us. The initial climb is going to be flight level 60, so let's move up to the autopilot controls. And down here we can select flight level 60. My personal advice, at 100 feet until IFR clearance has been received, just so that you immediately see that you are not cleared for this altitude just yet. Now, since we are not flying with ATC today, let's simply set the 6000 over there. Now, next up, we do have a 220 knot restriction on that departure. So let's go ahead and select the speed selector to 220 knots. You have two modes for the selector. There's either normal or there's V2. If you select V2, this is always going to target V2 up here on the speed scale. However, today we want to use normal because we have no reason to fly slower. This gets more important if an engine fails on takeoff. Then you can simply set this to the right onto V2, and then your autoflight system is going to target that. Next up, we ensure that the bank angle selector is set to normal, and not, for example, to 15 or 25, simply normal. And you do not want to pre-select the heading, so make sure that this stays dashed. It is SOP not to select any autopilot modes, so we are going to keep those blank, and the flight director switches are on. With that, our autoflight control panel is set up, and our route is also set up. Now, at the time of this recording, the secondary flight plan is not simulated yet. Otherwise, you could enter an immediate return on the secondary flight plan. If that is added later, then I might do an additional short tutorial on how to do this. For the time being, not simulated, so we don't have to worry about that. So the next step after entering our flight plan is to return to the init page and press the next page key. On the init B page, we can now enter all of our weight values. So we start with the block fuel. Again, the sensors show us how much is on board over here. So let's just add 5 tons block fuel. The zero fuel weight basically equals what we are about to load over here. And remember that if you are using GSX boarding, at some point you must actually select request boarding so that the boarding actually happens. Yes, the airplane is able to play cabin music. You can turn the automatic cabin music on the boarding off. And if you just want to stop it after it has already started, can do that up here. So I'm going to stop this for now, for the purpose of the tutorial. That's just something. So you do want to remember that you start the boarding eventually. Now we're looking at an estimated zero fuel weight of 29.2. So let's go ahead and enter those 29.2 into the zero fuel weight field. This calculates the takeoff weight, so 34 tons. And the moment you get this, you basically want to go down into the performance app and cross-check that the figure you used, 34.3 for us today, basically equals that weight. You could also recalculate the takeoff weight at this point, so why don't we just enter those 34 tons that the FMC tells us we are going to weight. So re-enter those, hit calculate, here's our updated takeoff speeds, easy. Now if you haven't done any preliminary performance calculation, do go back to that now, so that you know how heavy your airplane is going to be for the takeoff. What's important down here is the maximum, optimum and cruise flight levels. So the maximum and optimum are calculated based on the entered weather conditions and the weight. So got the weight over there, and you will remember the weather we entered down here, most importantly the temperature. So always make sure that your planned cruise level is below the maximum, and in the best case close to the optimum level that you see calculated down there. Today that's flight level 350. Now you could manually change things like the final fuel over there. You don't have to, but verify that it is set to 30 minutes. And you can see today that gives us 12 minutes of extra fuel when we arrive in Geneva. Now when the init B page is finished, we continue to the takeoff and approach page. Over here we are going to enter the takeoff speeds as calculated. So that's 123, 123, 131. So let's go ahead and enter that, where we got 123, 123, 131. Like this. The other figures you see over here are the flap retraction speed, which is 125. As you can see, that is below our V2, and that's again why we are doing a takeoff with flap 0 today. And then you got the clean speed of 160 over there. Basically between V2 and VFTO you want to limit your bank angle 15 degrees. Once you're above that, you can bank the airplane as much as you want to. On the right hand side you have the thrust reduction and acceleration altitudes, which are 1500 AGL by default. Now what do we need to enter over here? Basically there's two noise abatement procedures that are in use for jet aircraft nowadays. Noise abatement procedure number 1 and noise abatement procedure number 2. Number 1 includes a climb at the clean speed, so at 166 knots for us today, all the way up to 3000 AGL, and then you accelerate to the en route climb speed of usually 250 knots below 10,000 feet. So if you want to fly noise abatement procedure number 1, then you could type 3000 above the field elevation, so we make it easy, we assume a field elevation of 0 today, so simply 3000, put that into here. Noise abatement procedure 1 is usually used when you want to avoid noise that is distant from the airport. Then there is noise abatement procedure number 2, where the acceleration altitude is 1000 feet. That's basically used to avoid noise that is close to the airport by accelerating quicker and therefore reducing the time at which the environment around the airport is exposed to the noise that your airplane creates. Now, many airports also use a hybrid where you accelerate at 1500 AGL, which is the default figure in here and which is what we are going to keep for the purpose of today's tutorial. Finally, if you do expect to conduct a takeoff from an intersection, then make sure to select the takeoff shift up here. We don't want to do that today. However, since our airplane does not have GPS, it does update the FMC position the moment the toga levers are pulled, and therefore if you do an intersection takeoff, select that up here, otherwise your FMC position could erroneously be set to the runway threshold, even though you are, like we calculated earlier, for example 500 meters down the runway, which could then have an impact on the indications on your nav display once you are in flight. Now, with that, we have basically finished the setup of our FMC. If required, you could go to the progress page and tune any VOR that you may need down here, and you could enter your departure runway, so for example Echo Hotel Alpha Mike 36 left, in the field over here, so that you can easily see the bearing and the distance to that runway. That may be useful if you are doing an immediate return after the takeoff and might have to fly, for example, a visual approach. Alright, with that, our FMC setup is completed, and so we just make sure that our ND is once again prepared for the departure. And with that, we have basically completed our complete pre-flight procedures. So at this point, we can prepare our airplane for the pushback and the departure. In the real world, the moment that your load sheet is received, so when boarding is completed and everything is done, you would confirm the weight entries that you've done. So if we assume that our boarding has already been completed, we just go back to the aircraft page over here, and then it is going to show you your zero fuel weight over there, the total fuel and the gross weight, and with all of that checked, we would just reconfirm those figures in the FMC. So right now we got 29.8 as our zero fuel weight, so we can see we got a little heavier. So let's go down here and enter 29.8, like that. Okay, new takeoff weight 34.8, and if your weight does indeed go up, it's always a good idea to have a look into your flight plan again. So let's just do that. So we got a little bit heavier today. In your flight plan, you will always find this operational impact section. Now this one tells us if we get 1000 kilos heavier, we need an additional 48 kilograms of fuel. And look at that, we got even heavier, 29.9 right now. Okay, so let's go ahead and enter 29.9. So that's a takeoff weight of 34.7. So we got those additional 48 kilos fuel because we decided to load a bit extra in the pre-flight stages. And now we can also quickly run our performance again. Basically 35 tons. So hey, let's just go down into the performance and just run a takeoff calculation for 35 tons. Like this, calculate. Okay, still flap 0 and the speed's 25, 25, 33. So let's go down here. Takeoff page 125, 125, 133. We can then set the speed box on our speed indicator. My personal recommendation, only do this once the final load sheet is received, so that if nothing is set over here, it's a reminder to you that you haven't cross-checked the FMC yet. And with that, we are going to set V1, VR, and the clean speed, So starting with the clean speed, we got 171. Let's go ahead and set that bug over here. Then we got our takeoff speeds, 125, 125, 133. So I'm going to set that one to 133 and that one to 125. That way we now have quick access to the most important speeds for our departure. Alright, now let's set the flax temperature, and for that we go down to the thrust rating panel. We select flax on the top over here, and then we can quickly set this through the inner knob located over here. Now, as you can see, we need 50 degrees of flax temperature. The actual flax is shown to us up here, so let's go ahead and dial that up. And here we go, there's 50 degrees of flax together with our thrust, so we have an EPR of 1.59 for the takeoff and 50 degrees of flax temperature. Alright, now with that, our revised load sheet is completed. And with that, we can go right into the before start procedures. Okay, so let's go into the before start procedure. Let's request pushback through GSX down here, and while that is ongoing, we can prepare our airplane for the pushback as well. This would be the latest point to read the Powerup, pre-flight and preparation checklists, and then we can switch to the next set of lists by clicking the click spot on the side over here. And the next is going to be the before starting checklist. So the first step, if the APU has not been started yet, is to start the APU so that power is available once the external power is removed. Now, since our APU is running, we can disconnect the external power over here and then go over into the aircraft menu, remove the ground power unit, and once the ground power unit is removed, we just quickly verify that our parking brake lever is indeed set, and then we can remove the chocks as well. Note that in order to be able to remove the chocks, that is something that you may fall for, especially in the beginning when you get used to the airplane, the ground power unit needs to be completely removed. The moment you deselect this, it turns amber because they simulate the time that it takes for the ground crew to actually remove the unit. You can see still here, going to be removed in a few moments, and once it is removed, only then you can also remove the chocks from your aircraft, and only then GSX will be able to conduct the pushback. Okay, so our GPU is now removed. Then we check that the fasten seatbelt sign is on. We turn on all of our fuel pumps. We turn on the probe heat. Then we ensure once again that our takeoff data is set. We can set the FMCs, takeoff page on your side, and flight plan page on the pilot monitoring side. Then we are going to turn the transponder into the altitude offsetting or into XPNDR, depending on where you are really. So just use whatever is sensible over there. Verify that the windows and the doors are closed, and then we are going to announce arm slides on the aircraft panel over here.
Cabin crew, arm doors and cross check.
Like that. Alright. Lastly, the moment that your pushback clearance is received, turn on the beacon light, and now you should basically have an overhead panel that's completely dark, except for the flight recorder, voice recorder ground control switch, which is switched on. Okay, and with that, we are now basically ready to go. Now, read the before start checklist, and once that thing is read, and once GSX is ready to conduct the pushback, simply release the parking brake down here and make sure that the cockpit door is locked. Okay, so let's go ahead and select our pushback down here in GSX. It's going to be a standard pushback, parking brake released, and with that we are ready to go, and we are starting to move. Okay, and with all of that done, let's go ahead and start our engines. Once the engine start clearance is received, we are moving up here onto the engine panel, switch on the master switch, verify that the ignition is set to normal, and then we are going to start the engines in sequence first 2, then 1. Now, For the engine start, a very quick point over here. You can see our engine displays do not provide any detailed figures, you only see rough approximations of where the values are. Therefore, in order to make this a little bit easier for you to control, let's turn on the standby engine indicator up here. This is a backup instrument, this is not normally used during operations, but for the engine start, it gives you precise values, so we are using it over there. Okay, so we are ready to start the engine, so all you need to do is to hold the start selector onto the engine you want to start. So that's number 2 for us right now. With that, you can hear the bleed is turning off automatically, and now N2 is increasing, N1 is increasing. We verify the oil pressure on the gauge down there. You can see that is also increasing, and when we reach 15% N2, we are going to turn on the fuel switch. Now let's monitor the engine start. We can see that we do get TGT, which is the turbine gas temperature. So basically the temperature of the exhaust gas from your engine. And with that, our engine start is progressing. We're waiting until all the values have stabilized, which is roughly 54% N2. Okay, and here we go. Engine number 2 has stabilized, so let's continue and start engine number 1. Now our pushback is also complete already, so let's go ahead and set that parking brake again. And then we can monitor the engine start sequence over there. Again, we're looking for N2, N1, and at 15% N2, we can turn on the fuel like this. And now we simply monitor the engine start's progress. That was the generator kicking online, and with that the rest of the engine is starting as well. Alright, so the engine has stabilized, then we can turn the start push button to off. And with that, the engine start sequence itself is basically completed. So, here's our ground crew. We got the tug, which is a lifter, so no pin required, so no steering.
Cabin is secured.
No tow bar required, that's the word. Our ramp engine is going. And we are basically waiting with the after start procedure until the ground crew has completely cleared the aircraft, just in order not to cause any accidents. So let's go into the after start procedure. This is again pretty much straight from the checklist. So we set the anti-ice as needed. We set the APU as needed, and we do not need the APU for today's flight, so we can simply switch it off over there. Then we check that all the alert lights are out down here. Again, you could use the backup panel, but we don't need it since we do have our ECAM. We turn the ISD off. We set the flaps as needed, remember. Flap 0 takeoff for us today. We set the trims, and the trim figure can be obtained from the aircraft page down here. We can see we got 21.2%. So down here we are going to set the trim bug to 21.2%. So something like this. And we verify that all the ground equipment is removed. With that, the before taxi procedure is completed. So let's go into the taxi. The Fokker 70 and Fokker 100 only have an optional taxi light. So you can see this particular airplane is not fitted with a taxi light. Normally, once taxi clearance is received, the taxi light would be turned on. Since this airplane does not have a taxi light, which would be located over here, we can use the inner landing light as a replacement. So let's turn that into the middle to extend the light, and then on in order to actually switch that light on. Now, we are cleared to taxi to the Polder Barn, which is a fairly long taxi. So let's go ahead and have a look into the taxi chart to show you guys where we are going to go. We're standing right down here. Now taxi is going to lead us via Alpha, on a Alpha, Whiskey 5, Victor, Victor 4. And we're going to cross the runway in Victor 5. So basically standard taxi southbound, like that. Now, if you don't want to use that taxi chart over here, then you can just click Exit, use the en route chart, zoom all the way in, and that's going to give you your live taxi chart. In my opinion, a lot more useful than the standard taxi chart. Alright, so we verify that we are clear on the left hand side and that we are clear on the right hand side. Make sure that the taxi light is switched on, and then we can release our parking brake. Now the Fokkers do usually need a little bit of thrust to start moving. Once they're moving, it's normally fine. So let's go ahead and add a little bit of power over there. Once we're moving, let's do a little brake check to verify that the brakes are working, and then we're up and on our way. So, let's first of all talk about taxi speeds. If you are operating on a contaminated surface, so deep water, snow, slush, anything like that, limit the speed as far as necessary, that may be below 5 knots. If you're operating in turns that are tighter than 30 degrees, like we are right now, you should operate at a speed of 10 knots or less. A very light oversteering has to be applied, since there is a little bit of a distance between the airplane's nose gear and the airplane's main gear, which is located comparably far aft on the Fokkers, since, you know, got the engines and stuff over there, and the weight of the forward fuselage needs to equal the weight of the entire tailplane with the engines, APU and everything fitted into there, so that your airplane doesn't tail tip. So rather large distance between nose gear and main gear, therefore a little bit of an oversteering needs to be used in the Fokker. Now 10 knots as mentioned on tight turns, maximum of 15 knots when you're operating on aprons, and then a maximum of 30 knots when operating on long straight lines. Now we absolutely do want to go to those 30 knots when we are operating on a long straight line like we are right now, taxiing to the Polder Barn here in Amsterdam Schiphol. So do have that in mind. Finally, when we are operating on a wider turn like we are doing here, you see, we only need a very smooth steering here, then you can go a little faster than 10 knots, like I'm going 15 right now. You can see that's no problem. You will develop a feeling for your aircraft over time that's going to tell you whether you can do something or not. Okay, so here we are. Now we got a little bit longer line coming up ahead, so I'm adding a bit of thrust to accelerate over here. Also, since we are going to run uphill, you know, always anticipate that. Energy management is basically key when taxiing like any airplane, and on the Fokker it's just as important as on others. Now we got a good speed here, 25 knots. You can see our ground speed located on the top left of the navigation display down there, and with that I'm going uphill, losing a bit of speed while we're going uphill. Then I'm just going to keep that speed over here, because once we're going downhill it will start accelerating again. So planning ahead, keeping a good view on your energy status is key to taxiing any airplane, and the Fokker is absolutely no exception there. Alright, next up we are going to go downhill. That will gain us a bit of speed, and then we got to turn right over there. So have a look at the speed and how it's rising. Let's already start braking over here, so that we are going to be able to make that turn, because this one definitely is a little bit tighter than what we had previously. So I'm taking it close to 10 knots here. Here we are, 10 knots into the turn. Very slight oversteering. And here we are. Alright, now we got a long straight line ahead, so let's add some thrust and accelerate all the way up to 30 knots. Now, there is a little saying among pilots. Long-haul pilots always taxi slow, short-haul pilots always taxi fast. There is a certain bit of truth in that. Now, I learned flying on very short haul. I'm also taxiing the A330 at 30 knots. But you will notice that if you're looking at an airline where pilots learn on long-haul aircraft, think Emirates, think Aerologic, those type of airlines, you will see that they're generally taxiing pretty slow. That's because on long haul, you're usually making time up by just flying faster. On short haul, flying faster or slower is usually not going to have too much of an impact because you're just burning through immense fuel quantities without achieving any meaningful difference. The taxi, however, can make a difference. If you're taxiing to the polar barn at, 15 or 20 knots, it's going to take 5 minutes longer than if you're taxiing at 30 knots on long straight lines. So do aim for those 30 knots. Again, you don't want to exceed them because they are the limit, but if you keep your speed anywhere near there, you can see right now we're at a typical weight. Once I'm pulling the engines to idle, it's slightly losing speed. So we are going to let it accelerate a little bit, then we let it lose a little bit of speed again. If you keep the speed between 20 and 30 knots, you're operating rather well. Do anticipate upcoming turns. There is no need for us to accelerate again right now, because we know that at Whiskey 5 up here, we want to turn left and cross the runway. And, accelerating now, we would only have to brake and lose that speed again, which wears down the brakes and increases the brake temperatures, which is something to keep in mind. Now, as we're taxiing out, we are going to make the final selections on our autopilot panel. The reason we do it right now is because we would be reviewing our takeoff briefing right now. And the takeoff briefing would confirm the modes to be used. Now, that's usually going to be nav mode for navigation and profile mode for vertical navigation. So, if you want to bring this into Boeing terms, nav equals LNAV, profile equals VNAV. Level change, well, is level change. So, that one's pretty clear. Then you've got VOR localizer, and land basically equals the approach button. So, we want to select nav mode and prof mode. Then we want to verify. Well, we are crossing a runway, so just verify that there is no airplane and turn on the strobe lights as you're about to cross the runway. Now, continuing our taxi procedure there, we do select the autopilot modes. Then we verify that the fuel levers are indeed completely open. We are going to arm the lift dumper down here. The lift dumper basically is a spoiler on the wing. Our normal operations will never see us extend the spoilers on the wings, except for a rejected takeoff and the landing. Because the speed brake of this airplane, the one you control with that lever over here, works like this. So the lift dumpers have their separate button. So we do arm the lift dumpers, and then we verify that the squawk is in and the correct transponder mode is selected. And finally, we are going to unlock the flight controls down here. And once the flight controls are unlocked, we are going to test them full up, full down, neutral, full left, full right, neutral, and the rudder as well. Finally, when we are done with all that, we are going to select the auto brake into the RTO position. And do note that this only works when your engines are in idle. When the engines are above idle, I'm going to demonstrate that. I'll just take it back out again. See, we are getting a little bit of thrust right now. Then your auto brake is just going to show in up. You can only do this when the thrust levers are in idle. So let's just accelerate a little bit. And as soon as we got a good speed, I will just put the thrust levers back in idle. Now let's turn the auto brake to RTO, and you can see now the in-up light is not coming on. When we're done with the entire procedure, we press the takeoff config button down here, and if there is no alert, you'll see that right down here. If there is an alert because we've done something wrong, then you are going to get a warning from the airplane. So just to show you how that looks like, the flight controls are locked, and I press the takeoff config button. You can see it gives us a master warning, and it tells us what is wrong. Takeoff config, control locked. Okay, so let's go ahead and unlock those controls, and then we just get takeoff config norm. And that's it. So that's the taxi procedure completed. Now, the last thing that you want to do when we are approaching the departure runway is to cross-check the temperature of your brakes. Got the gauges down here, and you basically don't want to see high temperatures at this point. For an airplane that's been picked up from cold and dark, like ours has been just now, you can see very, very low temperatures there, maybe 30 degrees or something the likes, because we have applied the brakes, you know, a little bit. But what you do not want to see is either all brakes or any one of those brakes indicating a high temperature right now, because that would indicate that something on your brakes is stuck and therefore creating friction, and that would be an absolute no-go item for your departure. Now, at some point when you're taxiing in a straight line, do run the taxi out checklist, and then you can move ahead to the before takeoff checklist. So again, not a very sharp turn here, we can take this at a slightly higher speed. Just develop a feeling for this. Always remember, there could be people standing in the back of your aircraft, and you do want to ensure that those people are not going to be thrown around in your airplane. Okay, so we are approaching the departure runway, and with that, let's press the call button for everyone, all attendant call button, and that is going to... That is the signal to the cabin crew to take their seats for takeoff, and you will get a call momentarily from the cabin crew telling us that the cabin is ready for departure. Those strobes should be back off again since we've completed the runway crossing. Okay, and with that, our taxi procedures are complete. And as you can see, we can spend an entire taxi out to the Polderbahn in Amsterdam Schiphol on a tutorial flight, and we do have more than enough stuff to talk about. Alright, so for now let's go ahead and stop the airplane in front of the runway. When you do stop the airplane, always taxi up all the way to the line. You know, don't stop with the line visible over there, because then you're wasting distance. You always want to go as close as possible without actually entering. As you can see, there is a certain cutoff angle. There's your head, there's your fuselage. You can only view this outside. So there is a certain cutoff angle. And you basically want to make sure that you are not reaching into the taxiway behind you with your tailplane, and therefore you have to taxi all the way up to the line. A good indicator is normally when the line kind of goes right beneath the glare shield. So the line over there, and it's kind of going right beneath the glare shield over here. That's normally when you are really standing right up at your line. Okay, and that concludes the taxi portion of our tutorial. So from here, let's go into the before takeoff procedures. So the before takeoff procedures. We are just cleared to enter the runway. Again, we got the checklist down here. So the cabin has already been warmed with a call button up there. The takeoff config has been checked. The brakes are checked for their temperatures down here. Then we can turn on the strobe lights. Once takeoff clearance has been received, we can also turn on the landing lights. Then we are moving down. We are turning on the auto throttle. We are moving further down and make sure that our TCAS is set to TARA. Finally, turn on the weather radar by turning the brightness completely up. And while lining up, take a good moment to analyze the weather that is around your aircraft and within the departure path. Could there be anything that may be relevant for an immediate return? Just have a good look outside, line the airplane up, and normally you would conduct a rolling takeoff, but we are just going to do a static takeoff over here because I want to talk about the takeoff technique before we initiate the actual takeoff. At this point, verify you've completed the before takeoff checklist, read the checklist, and with that we are all set to go. Okay, so let's talk about the takeoff procedure in the Fokker 70 and Fokker 100. So the takeoff is a little different from your actual takeoff in, most other aircraft, in that you've got a couple things to do. First of all, during the takeoff, we are going to keep the control column slightly forward for the entire takeoff run until we're reaching the rotation speed. The reason for that is that the Fokkers have a tendency to lift the nose before reaching VR. No, that is not a bug. I know that some flight simulator aircraft do that as a bug, but the Fokkers have that behavior in the real world. So make sure that you apply some forward control column in order to prevent that. For the takeoff run itself, we are going to stabilize the engines at an EPR of 1.3, so here. And once they're stable at 1.3, we click the toga levers, which, could do down here, but there is a nice little hidden click spot on that screw over here. In order for that to work, you gotta have to arm the auto throttle system, otherwise that is not gonna work. Now, once thrust is set, we verify that it is right up here at the flex marker, and the thrust has to be set by the time we reach 80 knots. When reaching rotation speed, we pitch up to about 18 degrees on the Fokker 70, a little bit less on the Fokker 100, and then simply continue our climb to the acceleration altitude. Verify the FMA, where nav mode has to be on. So you can see the armed modes here: climb thrust, speed hold, nav. That is what we aim for our departure. The autopilot can be engaged rather soon after takeoff. There's no problems, no tight minimum engagement altitude or that kind of stuff over here. So you can use them pretty much as soon as you want. Now, we don't have to retract any flaps or something. So once we reach the acceleration altitude, we simply accelerate towards the speed limit, 220 due to today's SID, otherwise 250 knots. And that's pretty much it. That's how easy it is to take off in the Fokkers. Alright, so are you ready? Then let's go. So we are going to switch on the elapsed timers. Then we can stabilize our thrust at about 1.3 EPR. You do not have an indication for that, so you might have to, do a little manual experiment in there to find the correct setting. Here it is, 1.3. And then we just press the toga click spot and apply the forward control column. Verify that our thrust goes up to the flex setting, like this, by 80 knots, looks good. Remember, maintain forward control column pressure to prevent the nose from rising.
Rotate.
And here's rotation. So, pull aft, get the nose up, rotate to 18 degrees.
Positive climb.
Gear up. And here we are. So we are nicely climbing. We can use the autopilot, as mentioned, pretty early. We can just engage that, and now the automation is going to fly the aircraft up. And reaching our acceleration altitude, it will pitch down and we will start accelerating. For now, just verify that at the thrust reduction altitude, the engines are going down in the climb thrust like they are right now. The airplane is pitching down to start accelerating, and that's it. Now, VFTO, so the clean speed is indicated by the green dot on your primary flight display. If you did take off with the flaps extended, because for example you might have been on a short runway, then you can retract the flaps once passing the flap retraction speed over there. Now the airplane is automatically going to take care of everything. You can see it's targeting 220 knots in profile mode. It is automatically going to follow the route, and if you prefer manual flight over automatic flight, you can see the target heading to the waypoint up here. So you can kind of use that left-right indicator down there in order to determine how close to the actual route line you are, and you can use that target heading up there in order to place your airplane's heading onto the target. And that way you can fly the airplane precisely, even though the minimum range on the ND is 15 miles, and that may look a little confusing at times. Totally, you gotta admit that. Alright, we've passed the transition altitude, so let's simply select standard on the altimeters. Up there, and down here. And with that, standard is cross-checked, and we are passing flight level 42 now. Okay, now we're clear to climb to a higher altitude. We can set our altitude all the way up to the cruise level, which is going to be 350 for us. Set and cross-checked on the primary flight display. And with that, we are established in a nice climb. Now, let's take a second to have a look at our flight instruments and what they actually show, because I gotta admit, this looks a little different from what you are used to from most aircraft. So, the altimeter just tells you steps of 500s, and the 100s are included in those little markers down there. You do, however, have the exact altitude at the top right, and there's always the analog standby gauge, which, you know, you can use to make that a little simpler. When profile mode is active, the airplane is going to follow all the constraints automatically, so we are approaching the 220 constraint. Once we are flying past the Alpha Mike 045 waypoint, the airplane will start accelerating towards 250 knots, and once we are going through level 100, the airplane will accelerate towards the en route climb speed. And that is pretty much the entire takeoff for our Fokker. So let's go ahead and have a look into some of the climb items over here and what the airplane offers us in terms of avionics and everything that we need to take into consideration for our climb. So first of all, a couple of general words on the aircraft performance. You will see the Fokker doesn't climb too quickly. Now at the low levels you can do something like 2,000 feet a minute. 2,500 right now in the Fokker 70. The 70 climbs a bit better than the 100, of course, so something about 2,000 feet a minute. But as you're climbing to a higher altitude, your rate of climb is going to drop pretty seriously. So if air traffic control is asking you if you're able to reach any altitudes or if you're able to maintain a certain climb rate, you want to pay a close look. A rate of climb of around 500 feet a minute above level 300 is entirely normal and the Fokkers, so just take that in consideration. You know, half an hour to cruise level can absolutely happen. Now, we're passing 10,000, and that means we can switch off the landing lights and retract them, and then if it's smooth, which, you know, completely clear skies today, then we can also switch the fasten seatbelt sign off. There is no auto setting in the Fokker, it's really just on or off. The airplane is also accelerating to the econ climb speed, and that is a good indicator for us to just have a look at the different menus we got available down here in our FMC. Basically, the flight plan page is the flight plan page. You are kind of familiar with that. It tells us the ETA for a waypoint, it tells us the expected speed, and it tells us the expected altitude, which is fairly useful if ATC is asking you if you're able to reach a certain altitude at a certain waypoint. So this page comes in really handy. Then we have two pages here. We got the mode page and the tactical mode page. Now let's go ahead and have a look at the difference between the two, starting on the mode page. The mode page is basically your strategic mode, so it concerns the long time operation of the flight. Over here we got the cost index, which we can adjust. Then we can tell the airplane whether we want to fly econ speed, whether we want to fly a minimum fuel usage or a minimum time usage. Now, both have their reasons to exist. For example, if you know that delay can be expected, think about flying into London Heathrow. If you know that delay can be expected, then flying minimum fuel is going to provide you the greatest fuel savings. If you're flying to an airport where it might get a little tight with a night curfew, flying a minimum time flight would provide you the greatest forward speed. In any case, it also gives you your ETA for your destination and the expected fuel on board. Now the mode, or strategic mode, is the look at the entire flight and kind of determines your strategy for the complete flight. If you are just caring about the actual phase of flight that you're in, then you want to have a look at the tactical mode. You can see over here, you get information that is only relevant to your current phase of flight. So over here, we got the prediction to the altitude that's dialed up over here. And, you know, if you enter a different altitude over there, then is also going to give you the prediction to there. So if ATC wants to know how long do you need until you're reaching, you know, for example, flight level 310, just enter that over there. It's going to give you your time and your distance to that level. If you clear that, then it's going to give you whatever is set up here, respectively recognized up here. Now, on this one, you could also go into a maximum climb. Now, what maximum climb does is that it commands your aircraft to fly the best lift to drag ratio, so basically where the airplane can achieve the steepest climb possible. You also have your turbulence penetration speed, 250 knots, and you got the ability to select a custom airspeed in here as well. Now, this is quite useful if ATC instructs you to maintain any certain airspeed. You can just set it down there, and then the airplane is going to target that particular speed. Now, those are the strategic and the tactical mode pages of the flight management system. There is one more page that is interesting to check after departure. That's when you go onto the progress page, and then on the top right, you got the fuel prediction. Over there, you can see how much extra fuel is expected at your destination airport. So right now you can see 400 kilos, which equals 16 minutes extra are going to be on board of our aircraft when we reach our destination. So this is a pretty useful figure to check, you know, once you're past level 100 in a climb, so that you have an idea of what your fuel situation is going to look like at your destination airport. Also located on the progress page and important while you're climbing out are the cruise level, max level and optimum level. And on here you basically want to have a look at which level do you really want to climb to. So there's of course always the flight plan level, which is most of the time a good idea, however not all of the time. And over here you basically just want to check again, okay, my optimum is that, my maximum is that, and then you want to base the decision of the cruise level that you want to fly to based on those figures. Now personally, especially since the Fokker has such a bad climb performance at higher levels, I would always recommend to keep it close to the optimum. So let's take a theoretical approach here. Let's just imagine our optimum was flight level 340 and the maximum 350. Now we have to decide at which level do we want to cruise. If the optimum is 340, you could say, okay, let's just go up to level 350 because we are going to burn fuel, the optimum is going to rise with time. Now, while that is true and may make sense on longer flights, on the typical short flights that you're going to do with a Fokker, you would keep it below the optimum. So if we imagine an optimum of level 340 and a maximum of 350, I would usually pick flight level 330 for the cruise, just so that we stay beneath the optimum and have the advantage of a greater speed margin to our coffin corner while we're climbing and eventually cruising. It's also not going to drag the climb out for too long, because you will see in a couple of minutes that the climb performance is going to drop rather significantly once we get into the higher levels. Now, on the Fokker 100, that is a lot more dramatic than it is on the Fokker 70 that we are flying today, but the problem exists on both aircraft, so you just want to be aware of that and especially have it in mind when considering requests by air traffic control. Now, that much about our FMC and the information we can find in there. Let's take a quick moment to talk about some of the selections we can do on our autopilot while we are climbing. So you can see we got a couple of modes available on the speed and the heading knob. The speed knob basically gives you normal, which in profile mode is going to be managed by the FMC, so you get dashes up there. The heading mode can be engaged through the inner part of the knob. So if you want to maintain your present heading, you're going to press that knob in, and now the airplane simply maintains the present heading, as you can see on the FMA there as well. If you want to fly a specific heading, you need to pull the knob out, and now we can see the select button comes on, and that specific heading comes on over here as well. And you can see on the FMA this gives you a heading with an S behind for heading select. So heading as a mode means the airplane simply flies straight. Heading S means that you actually select a particular heading. Now if you want to return to nav mode, you're close to the route line, just press nav. If however you want to fly direct to a waypoint, so let's say we had to avoid some weather, we are currently flying, I don't know, let's say heading 170, and now we want to return to our route. Let's just select a nice waypoint over here, for example Turla. Then we can go down into the FMS, onto the direct page, and then simply select the waypoint we need, so for example Turla. By that, you can see the airplane now draws a route towards Turla, but it remains in heading mode. So unlike your favorite Airbus, which would immediately re-enter nav mode after entering a direct, you still need to select the nav mode manually in the Fokker. Now, what I would recommend at this point is that you re-enter the direct if you've missed that for a bit. Re-enter it so that it recalculates the route, and then press nav in order to return to your route without flying those oblivious S-turns going left and right of the route because you've overshot from the point where you created the direct. At this point, the Fokker does not anticipate turns, it simply draws a route line from the moment where you selected the direct. I do believe that JustFlight is going to update that for the future, but it is simply something to keep in your considerations as your flight is progressing. Now, let's just go down and have a look at the weather radar during the climb. For the takeoff, we had set a tilt of +5. Now, the weather radar tilt always refers to the horizon line and not to the pitch of the aircraft. So if you set +5, it's going to show you the weather on a +5 degree line. Since your aircraft obviously is not going to climb that steeply when you're up at higher altitudes, you do want to select this down. I would recommend that you basically go to something like 3 when passing 10,000, and then you can already go to something like -1 when you're passing through 20,000, because at this point what matters the most is the weather that you're going to find below you. If you find weather above you, by all means use the tilt in order to analyze what that weather looks like, but especially at higher altitudes, keeping your tilt on something slightly negative is usually the better option, so that you see what's going on somewhat below you. Now, as we're climbing and gaining altitude, every 10,000 feet we want to cross-check that our cabin pressurization is working normally. So we're just about approaching level 300. You can see our rate of climb has dropped, as I have announced earlier that it would. So let's have a look at the cabin pressurization panel at this point. We've got the differential pressure shown over here. The differential is the difference between the pressure of the air outside the aircraft and the pressure of the air inside the aircraft. Now, when passing 10,000 feet in a climb, you want to see this gauge somewhere close to 4, with most aircraft's typical pressurization schedules. In the Fokker, a little bit less, because the cabin rate of climb isn't that strong, so it pressurizes rather slowly. Now, therefore, you may see a little different, but something close to 4. As you're climbing through 20,000, you're looking at about 6. As you're climbing through 30,000, you're looking for something between 6 to 7. And that's the normal differential pressure values. Next up, we want to have a look at the cabin altitude, and that one is climbing slowly. If you're climbing, through level 300, for example, and the cabin altitude is somewhere here, you fucked up. In that case, the airplane is not pressurizing properly. Now, I want to keep this tutorial to normal procedures, so I'm not going to go into the abnormals and how to fix that, but do Google for a Fokker QRH and you may find something in there. Lastly, we got the cabin rate of climb, and that is the actual vertical speed of the cabin itself. There is a common misconception among flight simmers that passengers would care about your aircraft's vertical speed. They do not. Not at all. That's because they can't feel it, they can't see it. We're humans, we aren't birds, our organs aren't made to sense vertical speed. What they do sense though is the change in pressure. And the change in pressure is your aircraft's rate of climb, or rather your cabin rate of climb. That one, as you can see, is a nice 100 feet a minute over here, or 200 feet a minute over here. You know, while the actual airplane is climbing at 1,000 feet a minute. 1,000 feet a minute would be very uncomfortable for the human being. So, you know, if your passengers felt this, they would be very unhappy. However, since the airplane only climbs currently at 300 feet a minute, every one of those notches equals 200 feet a minute. That's completely fine. Your passengers will be happy. Now lastly, let's talk about the use of anti-ice throughout your climb. Even during summertime, anti-ice can and will be required in the climb. I know it's very easy to forget when you would love to come to the airport without any sort of shirt on just because it's 35 degrees outside. Totally makes sense. But according to the ICAO standard atmosphere, the outside temperature is decreasing by approximately 2 degrees per 1,000 feet altitude. That means as you're getting to higher altitudes, it's getting really cold outside. Now, if you do have clouds or visible moisture, just like when we discussed the usage of engine anti-ice throughout our departure, the moment your temperature drops below plus 10 degrees and you have visible moisture, you want to turn that anti-ice on. Now, what do we normally do? During the climb, when visible moisture is present, so when we're flying into clouds, rain, snow, whatever there is, and the temperature is a TAT of plus 10 degrees or less, that's when we turn the engine anti-ice on. And that is only what we turn on, just the engine anti-ice. Now, should we enter actual icing conditions, remember, we are using the engine anti-ice when we're anticipating icing from happening. That means those clouds are present, we're about to fly into them, temperature is a TAT of plus 10 or less. We turn engine anti-ice on. The reason we do this on a preventative measure is because engine anti-ice simply heats up the intake over here. Imagine if we forgot the engine anti-ice. Ice will build up on the intake of the engine. If we turn the engine anti-ice on now, the bottom of that ice starts melting, and the airstream is going to either, in the good case, make the ice drop off to the outside, or is going to take the entire ice block and ingest it into the engine. That can quickly damage the engine. That's the reason why we are using engine anti-ice on a preventative basis. It's the exact opposite when it comes to wing and tail anti-ice. So wing anti-ice heats the surfaces over there and over there. Tail anti-ice heats the surfaces up here. So wing and tail anti-ice are only used when an actual ice buildup is recognized on your airplane. How do you recognize that? Well, you are going to get ice on the wipers, for example. The moment ice is building up on your wipers, that's normally a good indicator that ice is also building up on the wings. Only when you see that, wing and tail anti-ice are going to be used. The reasoning here is that if you heat up the leading edges and you are flying through icing conditions, that ice may hit the leading edges, melt, flow backwards on the wing, and then freeze on the cold part of the wing over here, or the cold part of the stabilizer over here, since only the leading edges are being de-iced. You don't want that, because you couldn't remove that ice. For that reason, use wing and tail anti-ice on a reactive measure, and engine anti-ice on a preventative measure. Now, we're about to reach our cruising altitude here. There is one last thing we need to talk about, and that is your rate of climb. Now, to avoid any nonsense TCAS conflicts, use a maximum of 3,000 feet a minute when you got 3,000 feet to go to your cleared altitude, 2,000 feet a minute when you got 2,000 to go, and 1,000 feet a minute when you got 1,000 to go. These are maximums, not targets. You could see how we had about a 700 feet a minute rate of climb when we approached the altitude here, so therefore we could leave VNAV in. Now we are reaching our top of climb, and with that we can start entering our cruise procedures. So let's go ahead and have a look at what we are going to do. So the first thing we normally do when we reach the top of climb is to set our TCAS mode selector to below. The reason we do this is because we no longer care what is above us, and remember, TCAS is always going to show you the traffic within plus minus 2,800 feet. The above and below selector only extends the appropriate direction by another 7,000 feet. So, since the only thing we care about now is the possible emergency descent, that's why we put the TCAS mode selector to below once we reach cruising altitude, so that we can monitor what is going on around us. We'll also want to keep the tilt of the weather radar somewhere around -1, so just make sure that the tilt shows roughly -1. Reaching our top of climb, the next thing we want to do is conduct a fuel check. So right now we took 23 minutes to get here, and we got a fuel of 3,630 kilograms on board. So let's go into our flight plan down here and have a look. So by the top of climb we should have taken 19 minutes with 3.2 tons of fuel on board. So we did take a few minutes more, and we have an additional 400 kilos of fuel. The fuel absolutely makes sense because we did load additional fuel on the ground. The extra time is probably just a slight inaccuracy of the SimBrief profile for our Fokker. Now, the next procedures are all going to depend on what time we're expecting to have in cruise. Today we got a little longer flight. If we scroll the range out over here, we can see our top of descent is way out somewhere over there, so we do have a little bit of time available. However, you always want to visualize when you want to start the descent procedures, and I would recommend to start the descent procedures when you are roughly 100 miles from the top of descent. So always have that in mind, and that is going to determine what you are going to do up in cruise. Now, a couple of checks for us to do. We've already had a look at our fuel at the top of climb. However, we also want to do that over at least one waypoint, because the top of climb, as you have just seen, is a dynamic waypoint. Due to the fact that we took 3 minutes longer to climb up to the top of climb, that fuel estimate was of course not accurate either. So next up, we got Sutal, which we should overfly 32 minutes into the flight with 2.7 tons of fuel on board. So when we overfly Sutal, that's when we want to do another fuel check. Apart from that, we are mostly carrying out monitoring duties right now. So we are looking, for example, at the distribution of the fuel. You can see the left side has burned a little bit more than the right hand side over here. However, we also started the left engine first, and most importantly, the APU is also getting fuel out of the left tank. Since we did run the APU for approximately an hour on the ground, that's why we have less fuel on the left hand side than on the right hand side. Now, you could consider fuel balancing, however, I would only do that if the balance exceeds 300 kilos. Then you turn the cross feed valve on over here, and you turn the low side fuel pumps off. So just to show you what that looks like, cross feed comes on, we observe the line, then we turn the two left hand pumps off. Always low must go, so that only fuel from the higher tank is now used for both engines. Alright, in order to turn that back on again, first the pumps, then the cross feed off, so that the left engine isn't getting drained. Alright, now with that, we're up at cruise level, we're enjoying ourselves, but what if weather would be anywhere close by? Let's have a look into how to operate the weather radar since JustFlight do simulate the tilt function of the radar. This is especially important when it's nighttime, but just as important when it's daylight and you want to judge whether you can fly over a weather cell or whether you should fly around it. So we got our weather radar over here. We got a 40-mile range and an 80-mile range. Depending on your range selection, that's of course going to vary, so do select an appropriate range. Now, what we normally do is to have a look at the tilt. So let's say we had a weather cell over here, right on our flight path. The tilt is set to -1. The indication we see over there at the 80-mile range with the tilt of -1 is what actually is 8,000 feet below. That's easy to remember. If the tilt is -1, then your distance over here times 100 equals the altitude. So 80 miles out, tilt -1, 8,000 feet below you. So when a weather cell comes up, you basically want to analyze it by slowly changing the tilt. For example, let's go to a tilt of -2. Now, this is no longer 8,000 feet, but 16,000 feet below us, if something is 80 miles out. That way, you basically want to analyze where are the tops that may be dangerous for you. So, if the tilt is at -1 and the returns stop 80 miles out, then we know that the weather is 8,000 feet below us and we can safely fly above that. Depending on what type of weather it is, you want to keep a distance, 4,000 feet if you're at lower altitudes and it's not so bad. At high altitudes, thunderstorms, you want to keep at least 8,000 feet distance. That's why it's so important to check this early enough that you can determine where the weather is, what it looks like, and whether you can safely fly above it or not. Now let's take a quick moment to talk about the aircraft's navigation systems. Now, the Fokker 70 and Fokker 100 are not equipped with GPS. Much rather, they are equipped with conventional navigation aids. So, how exactly does all of that work? Now, the FMS determines what is called the FMS position. That is calculated by the input from the IRS. So we got the present position selection over here. So it takes that. However, the IRS is going to drift. And therefore, our navigational accuracy decreases over time. Certain procedures can be done in order to mitigate against that, and before you're completely freaking out now and not even bothering to do another flight with the Fokker, don't worry, that happens automatically. So you don't have to worry about that as long as ground-based navigation aids are available for your aircraft. So, how's all of that gonna go? Now, the FMS is automatically going to tune navigation aids, as you can observe on the lower line of the progress page. For example, down here we have Brussels VOR, and then we got that Bravo Bravo Echo, whatever that is. You can see on the RMI that the airplane is receiving the direction and the distance from Brussels, and it's also receiving the DME from that second station. You will notice that the airplane is not always going to give you the closest navigation aids, but it is much rather going to default to some navigation aids that are slightly further away. Now, what this means in practical terms here is that we've got a distance and a direction from a point where the FMC absolutely knows where it is. So for Bravo Uniform Bravo, it knows where it is. We can go onto the nav aids page over here, look up Bravo Uniform Bravo, and you can see it knows the exact distance of where that particular VOR is located. Therefore, by now seeing okay, it's that direction, that many miles, the FMC can calculate the error of the IRS position and then automatically apply a correction to that in order to mitigate against that error from the IRS. The most precise way of determining your position is by having two DMEs, because in terms of lateral deviation, a VOR has certain error tolerances. In terms of distance, however, it's very, very precise. Therefore, if you have two DMEs available, you get the most precise location. If you only have a single DME and a VOR, it gets a little less precise, and if you have no DME at all, but two VORs, it gets even a little less precise. The FMS is constantly monitoring how accurate it is and how good of an error correction it can make. If it determines that it is no longer able to assure a certain navigational accuracy, it's going to warn you about it, and then you have to tell our traffic control that you no longer meet the navigational standards. Now, what kind of navigational standards can the Fokker actually fly? So, most of European en route airspace is RNP2. RNP2 means that the FMS has to be able to calculate its position within an error tolerance of 2 nautical miles. Now, that is no problem at all. All it means is that your map that you have over here has to be within 2 nautical miles of the real position. Most SIDs and stars and approaches are RMP1, so the maximum error could be 1 nautical mile. You cannot fly RMP-IR approaches or approaches that have a required navigation performance of 0.3 with the Fokker, because the ways that the Fokker FMS has to correct its position are not precise enough to guarantee 0.3 miles reliability for your performance. So RMP1, which is your typical RNAV sit, RNAV approach, it can do, but not RMP 0.3. So RMP AR will not be possible with the Fokker, and RMP approaches where a certain RMP of less than 1.0 is specified on the approach chart can also not be flown with a Fokker. So generally speaking, summarizing this, the navigation system in the Fokker, even though the airplane has no GPS, is capable of flying to pretty much the same degree of accuracy that the navigation system in a 737 or an A320 or any airplane with GPS can do for any operations except for RMP AR approaches or similar RMP approaches that require an RMP of less than 1. The majority of RMP approaches is RMP 1.0, so you will not need a GPS in order to be able to fly them. The Fokker will be able to fly most of them, but not all of them. So that much about the navigation system. So now we've talked about a lot of things over here, and since the Fokker is a short-haul aircraft, let's go ahead and start to prepare for our approach. So let's go ahead and talk about the descent preparation procedures. Now, as always, the first thing you want to do in order for you to prepare your descent is to figure out what is the weather like. Now, we've got a couple of ways to do this. You could go into the OFP page and then onto the metas, hit refresh, and that's going to get you your latest weather. However, this is good when you want to know about your alternate as well, but I would do this over the performance page. Go onto the landing field, calculate your destination, so we got Geneva, runway 22, and then import live weather. You can see this is going to import the latest current weather down here. So we got variable 2 knots, cavalcade 25 degrees, QNH 1019. The moment we get a QNH, we always pre-select it. So there's pre-selection over here and over here. 1019 is pre-selected. Now, That's just because it happened to be the same QNH over in Amsterdam. Normally you would have to dial this in. There is no automatic transfer there. So let's go over the landing performance. We got a runway in meters, and if you just reselect the runway, it's also going to show you meters. Then you got the braking action. Now, good is what's taken like 99% of the time. In order to get the actual braking action, have a look at the either ATIS in the winter or the snow tam, and that's going to give you the estimated braking action. I'm not going to go into more theory here because that would cover its own video, and I've done that in my winter operations tutorials, so if you're interested, have a look in those. Then we got the auto brake. By default, we'll always want to calculate low in order to keep the brake temperatures low and therefore keep the turnaround times short. Then we got the anti-skid, which is normally operative. We got our wind, and if you got a variable wind, I would always recommend to enter a direct tailwind. So we're landing on 2-2, so let's enter 020 or 040 at 2, which is an exact tailwind for the approach. Next up on the right hand side, we got the runway slope, which is automatically taken from the database, and then we got the landing flap setting. The Fokker is certified for 2 landing flap settings, and that's either 42 or 25. Now, 42 provides you with a little more drag, makes the approach a little bit more stable since you have more drag, and is of course going to shorten your runway distance required, or landing distance required. Now, it also uses more fuel, and therefore, since we have a long runway, 3,900 meters, let's calculate flaps 25. Runway surface, you got either dry, wet or contaminated. Ours is going to be dry today. And then we got the landing weight. The landing weight can quickly be obtained from the FMC on the takeoff and approach page. Up here you got 31.5 tons. So let's go right over here and enter, what's that, 31.5. So let's just go ahead and type that thing in manually, 31,500. Alright, with all of the figures available, let's hit calculate, and then you get the landing distance you need, and you can see our factored landing distance is 1,456 meters, and that's already with flaps 25. So, just to show you, 1456, if we took flaps 42, it's going to save you about 100 meters. At the cost of extra fuel, in the majority of cases, that's not going to be a problem at all. So we are just going to do a flaps 25 landing. We can only calculate auto rates low as lowest setting. However, what I would recommend in most situations with a Fokker is just to leave the auto brake completely off. Because most airports are designed to have the first exit at about 1,800 to 1,900 meters down on the runway. That means if you do use the auto brake, you're gonna slow down pretty early. Under most of those situations, just keeping the auto brake off and using idle reverse and then manual braking in order to vacate the runway is going to be the much more efficient option. Also considering brake wear. Okay, so that's what we got there. That's our landing calculation. Then let's go ahead and have a look into the approach charts, which is always the second step on an approach. So we can click arrival down here and pick our charts. We got the Quito 3 Romeo arrival. Our approach is going to be an ILS to runway 22, and then we got an airport chart which we can pin, and a parking chart that we can pin. And then let's just go to the saved tab. We can remove our departure airport charts here, and now we got everything we need readily available in the electronic flight bag. So let's go ahead and start with a bit of a setup over here. Now, the first thing we want is for the FMS to be able to calculate properly. So let's go onto the progress page, and over here we got the descent forecast. Let's go there and enter our descent winds. Those are available from the flight plan. You always have a wind data block somewhere, and then we got the descent block in there. Now, depending on your altitude, I would enter anything sensible there. So we got a cruise level that's at or above 310. So let's start with the winds at level 310. So we type 310 for the altitude, slash, now the direction 097, and now the wind speed at 12 knots. Then we can enter that over here, and that's the first winds in. Next up, let's take level 200, So we got 200 at 97 degrees and 8 knots wind speed. Can enter that. And then we got level 100, where the wind is shifting a little bit, 197 degrees and 6 knots. Lastly, we can enter the wind from the runway as well, which is variable 2 knots. So let's just enter 0/0. You do not need to enter the airport over there. And that's our ground winds. Okay, and that's the forecast in. The VNAV system is going to use this to calculate the vertical profile more precisely. Now from there, we can move on to the flight plan and check that the entire arrival we've entered makes sense. So first of all, we can see we got Akito twice with a discontinuity in there. So let's remove the first Akito and let's remove the discontinuity. That way, we're now getting one continuous route, and that should also help the aircraft with the calculation of the topper descent. Now, once we've done that, we can go ahead and continue checking all those waypoints against the chart and making sure that what we've got in the FMC equals what we should have for our approach. So, from Akito, we're going to fly to waypoint 518, Bolgi, Lirko, and for that, I would again recommend to use plan mode. So we got Akito, 518, Bolgi, and then Lirko. Like that. And for Lirko, we also have the 250 knots and the 8,000 foot restriction that we can see down there. From there, we continue via Dinek towards Sovat, again 250 and 8,000. And then we are going to continue via 507 and 514 into the downwind. And when we look down here, we can see that we got all of that stuff down in our FMS. Now that's eventually going to lead us to the final approach. Now, in order for the FMS to be able to calculate a decent vertical profile, always have a look at the altitude prediction. You can see over here, due to the vector lag that we have over here, it's giving us a manual termination and a flight plan discontinuity. Leave those in, but give it a proper altitude constraint for the descent. Now, what do I mean with give it a proper altitude restriction? Basically, we want to ensure that we got a decent vertical profile. So what are we going to do there? Now, we could absolutely expect air traffic control to give us some shortcuts, for example, from Akito direct into the final approach, so to Saper. Now what you could do there is to delete all those waypoints in between and then see which altitude it predicts for Akito. Alternatively, if you don't want to do that because you would have to re-enter all that stuff and that's a lot of work and pilots are lazy, so we don't want to do that work, you know, just scroll out a little bit. You can see, okay, from Akito to Saber is maybe, call that 45 miles. 45 divided by 3, because by default you will lose 1,000 feet in 3 nautical miles, is 15. So Saper should be in 7,000 plus 15. So we're looking at roughly 22,000. So we could enter a manual constraint of 22,000 for Akito. You can either do that with a slash, but then you have to type the full thing. So like 22,000, like this. Or you go to the vertical revision page over there and then just enter it as a constraint. And that is going to give you a little more accurate VNAV data. So for the purpose of today's video, let's just keep that thing out. Let's hit clear altitude down there, just to remove that constraint. But you should enter something like that, especially when you see that it's not calculating accurately like you have over there. So let's go ahead and enter an 8,000 restriction exactly at that last waypoint before the vector lag. That way we should get a good topper descent calculation. And now it's just recalculating. Let's just re-enter that cruise level real quick. Okay, And with that, it should show you your top of descent over here. Looks like we're just about to reach it, that's why we're already getting a VNAV profile. But you get the general idea of how to do this. Now, in order to finish our preparation, we just have to enter a couple more things. The Fokker does not auto-tune your approach figures. So we got an ILS frequency of 108.7 and an approach course of 223. Gotta tune those manually down here. 108.7 and 223 degrees, like this. And then we also gotta enter the minimum. The Fokker is a category Charlie aircraft in case you have different minimums available. Now we do have a gradient of 4.2, so we can use the 1565 feet minimum available over here. The Fokker only accepts minimums in steps of 10s, so let's go ahead and dial up the next highest. So 1565 becomes 1570. That we gotta set on our side as MDA. Only use DH if you plan an auto landing. And then we can also set the same thing on our first officer's side, 1570, like this. Alright, with that, we have pre-selected everything that we need for the approach. Finally, go down into the FMS, onto the takeoff and approach page, select the landing flap that you want to use, and that gives us our approach speed. Now, Fokker is kind of interesting. They do not want us to do a manual wind additive to the approach speed if the wind is less than 10 knots. Only if it's more than 10 knots, then we are going to add 1 knot for every knot extra than those 10. So, plus 25, 133 knots. Let's go ahead and set that speed bug to 133, like that. And then we can also set our clean speed, 169, up here. And that's it. Alright, and with that, we have now set our airplane up for the approach. So let's go ahead and talk about the initiation of the actual descent. There's 2 ways that you can do this. Now, when ATC clears you to descend when ready, then what you're gonna do is just to dial in the altitude. For example, we're gonna take 8,000 feet today. And in order to arm the descent mode, simply pull the altitude button. Now, if you're prior to the top of descent, your airplane is going to maintain cruising altitude, and then eventually going to start the descent when you reach the top of descent. However, there's quite a cool feature. Now, if you have not reached the top of descent, unfortunately right now the airplane seems to think that we have reached it already. Let's see if I can reset that somehow, because there seems to be a little bug involved. Right now, let me just reset that cruising altitude. Okay, not really. Okay, there is a small bug that prevents me from showing this, but let's just go ahead and talk about it in theory then. So, if descent is imminent and the airplane has the descent mode armed, you are going to get an immediate descent prompt on the top right of the FMS. When you arm that, your airplane is going to start a descent at 1,000 feet a minute until it intercepts the actual VNAV path. Now, I'm just wondering, if I remove the manual termination over here, is that going to give us a proper VNAV path calculation? Always a pity if you encounter a bug during a tutorial. Let's see if I reset this. No, not really. Okay, that's a pity. That's a little bug there. Of course that has to happen when I'm recording a tutorial, but okay, so be it. Normally the VNAV is a little better here. Anyway, let's say that we've done this immediate descent and we're now descending. You will eventually get that IP point on the nav display. That means intercepting profile at that point. So that's where the FMS is going to intercept your profile for the approach. Now, let's go ahead and talk about what our options are then for the descent. So if you use the immediate descent option, the airplane is just going to start descending until it intercepts that point. If you set the altitude down and pull the knob, it's going to arm descent mode and start the descent automatically when you overfly the top of descent. It's very important though that you pull that button in order to arm the descent mode. If you don't do that, the airplane is not going to initiate a descent. Now let me see if I can force it to start the descent a bit earlier here, because this is a little unfortunate right now that it is bugging around. Let's say I want the 8,000 feet or below constraint there. Now you can see that VNAV is coming in, and now it enters descent mode, and now it intercepts the vertical profile and starts a normal descent. One thing that's important to check is that we got the correct landing altitude set, so that's up here, 1,400 feet. So let's make sure that we have selected that for our descent. You should cross-check that during the descent preparation. I forgot, shame on me, but here it is, pre-selected. And with that, we are now starting our descent, and we are heading right down along the VNAV path over here. When we're descending, and when we are not on the target profile, you will see the vertical deviation on the top right of the progress page, like this. Now, we've left our cruising altitude, we're on the way down. At some point, we need to turn on the fasten seatbelt sign. All airlines have different SOP there. There is no doubt that we cannot cover them all, but one thing that I can cover over here is two of the most common ones, especially with short-haul operators. Now, you may be used to airlines turning the fasten seatbelt sign on when they start the descent. That is true. However, on short haul, that's typically not what is done, because turning the fasten seatbelt sign on is also assigned to cabin crew that you are going to start a descent, and therefore for them to stop the service. Now, especially on those very short 30-minute flights, that's not what you want to do. Instead, you will turn the fasten seatbelt sign on at a specific time from your destination. Remember, the time to destination is visible on the mode page up here, 0743 for us. And what I would recommend is 15 minutes before reaching your destination. So 43 is the ETA, minus 15 is 28. So at 0728 we are going to turn on the fasten seatbelt sign. Now, since it's basically that time, let's go ahead and, for the purpose of the tutorial, turn the fasten seatbelt sign on right now. So as we're descending, we need to think about anti-ice again. Now, for the descent, the same conditions apply that also applied for our climb, with one little exception. In the climb, when the SAT reaches minus 40 degrees and colder, you can turn all the anti-ice off, because the water in the air is so frozen that it's just going to bounce off your aircraft and therefore not going to freeze to your airplane. In the descent, since we're descending into warmer air, we will turn the anti-ice on the moment we have visible moisture and the temperature is plus 10 degrees or less. Immediately turn on the engine anti-ice, and just as in the climb, when an ice buildup is observed on the wiper, also turn on the wing and the tail anti-ice. And again, this is going to happen in summertime as well, because you can see how cold it is up here. Now, once the TAT reaches a temperature of plus 10 degrees or higher, the engine anti-ice can be turned off once again. Now with this we're descending. When descending, it's always a good idea to keep an eye on your vertical profile. So how do we do that? We take the altitude, ignore the zeros, and multiply by 3. So we're passing 25,000 right now. 25 times 3, 75 nautical miles that we need for our descent. And we can see the airport is about 50 nautical miles away, but we do have that standard approach here. Now, if ATC would advise us that we could expect a straight in, this would be a good point to increase our rate of descent. If we expect to fly the entire arrival, then we can remain on VNAV over here, and we can check the remaining distance along the flight plan on the progress page down here, where we can see we've got 97 nautical miles to run along the flight plan. So along the flight plan, we're actually a little bit low right now. Let's talk about the different autopilot modes that we have available for the descent. Obviously, VNAV is the default mode that we could use. Now, there are two other modes available. The first one is level change. When you go to level change, the airplane is going to go to idle thrust and simply maintain the speed commanded over here. You can switch this between Mach or indicated airspeed, like this. Now, the other available mode is vertical speed. In order to enter that, simply dial in a vertical speed. You don't need to press any button. The moment you dial this in, you can see that vertical speed mode immediately comes active, and that's it. So, profile is your vertical navigation. Level change, it simply goes to idle and maintains the speed that you dial up. And then there is vertical speed if you really want to go to a specific setting. Now, let me demonstrate one thing over here. That's the usage of the speed brake. The Fokker has speed brakes located at the back over here. The big advantage of that is that the speed brakes do not disrupt the lift over the wing. Therefore, they are not as uncomfortable as they are in most aircraft where the spoilers are located on top of the wing, because you do not get all that shaking. However, the speed brakes are incredibly effective in the Fokkers, and you want to ensure that you do not end up with a 10-degree pitch down. Because when I explained on our way out or on our way up that passengers don't feel vertical speed, which is absolutely true, the passengers do feel the pitch of your aircraft. So if you just pull the speed brakes and go all out, then you are going to descend at an incredibly steep angle. So what I would recommend for using the speed brakes here, since while this is a lever, they really only have the retracted and extended position. There is no in between. You can see that over here. When I'm moving this, it's just in and out. There is no in between. So let's go ahead and have a look over here. Now, in order to use the speed brake and to prevent the airplane from pitching down excessively, what I would recommend is to go to vertical speed, select what you want to use, so for example 3000 feet a minute, then just reduce that speed target so that autothrust doesn't start adding speed, and then, you know, let's do 3500 here. Now the airplane starts accelerating a bit because it doesn't have sufficient drag, and if you now use the speed brake like this, you will see that we are losing that speed again. That is how I would recommend usage of the speed brake on the Fokker, just to make it a little more friendly for your passengers. Now, as we're getting below the VNAV profile, you can immediately see that over here, profile is above, and we are now 600 feet below the profile. Every one of those dots equals 100 feet by default. If we press the profile button while we are below the VNAV path, the airplane is going to go into 1000 feet a minute rate of descent. And you can see that it calculates the position where we are going to re-intercept the vertical profile. And it eventually recalculates the VNAV profile. And as you can see, we're now re-intercepting the profile on our way down. It's also going to go back up to the 270 knot target. And that's it. Now we're passing 15,000 feet. That is the latest point where we should turn the fasten seatbelt signs on, so that the cabin crew have sufficient time available to prepare the cabin for our arrival. Now, there's Geneva, there's the airport. Let's go ahead and take a little shortcut for our approach. So let's imagine that air traffic control starts vectoring us. If you want to enhance your situational awareness, you can just go onto the B modes on the nav display. So let's say we want to go somewhere over there, like a heading of 130. Let's go ahead and dial that heading up, like 130. Pull the heading knob, now in heading select, as we can see over here as well. And Fokker recommends that when you're flying in heading select, you should also go to level change, because VNAV cannot be trusted when you are not flying on the FMS route. Okay, so let's have a little look at the approach chart. MSA in the north is 7,000. So let's go down to those 7,000 here. And just clean up our flight management system in order to get a little better idea of what we are actually going to do. Let's turn further left, say heading of 100 here, just to vector ourselves into the direction of the approach. So let's go ahead and clean up the flight plan. That heading basically leads us to Saper. So let's clean the FMC up by also adding a direct to Saper over there, assuming that air traffic control is not going to need us on any of those waypoints from the star any longer. By entering the direct to Saper, we now get a new VNAV path, and we now get the new remaining distance along our flight plan. So that is some pretty useful stuff that we have available on the aircraft over there. Now let's take a very short moment to talk about what we've got available on the tactical mode page of our FMC descent. We've again got Econ and then maximum descent, where the airplane goes to maximum speed, and you can also enter a custom speed. Then we have a prediction how long it's going to take until we're reaching a certain level, and over here you can also enter that manually again. So for example, you could go to flight level 80 to flight level 70, basically whatever you need over there, and it will tell you how long it's going to take, and if you clear this, then it's going to recalculate for the altitude that you've dialed up over here. And that's basically how this page works. Now we are going through 10,000 over here. Let's go ahead and make a couple of settings. So first thing, we'll verify that the seatbelts are on. Then we are going to turn the outer landing lights on. The inner one could be used as a reminder for whether you've gotten your landing clearance or not. If you have an airplane that's fitted with a taxi light, I would recommend to use that. Otherwise, since we are flying without ATC today, let's just turn that on right now. We also check our air condition and pressurization to make sure that the cabin is descending properly, so that we're expecting to be down at field elevation by the time we actually reach the field. Okay, we're cleared to an altitude. The QNH is pre-selected down here and down here, so let's select the altimeters to QNH. 1, 2, and 3. Like that. And with that, QNH is cross-checked, we're descending, nice, easy, done. Now, in order to be able to view your ILS data, you've got to select the approach VOR button over here. You can do that when passing 10,000, analog to pressing the LS button in the Airbus, or you can do it a little bit later, completely up to you. Okay, so let's say that air traffic control is cutting us short a little bit and vectoring us onto something like this. Let's say 130. Let's go ahead and update our flight plan once again. We're also just getting a further descent down to 4,000 feet. So let's go level change and start our way down. And then we can update the FMS, say with a direct to Golf Golf 808, like that. Just to, you know, cut us short a little bit. And now we got to do a little energy management exercise here. So we've got about 6 miles to the center line, we are still pretty fast, and we're a little high. That's a good moment to go to vertical speed mode. You know, select an appropriate vertical speed. You can use the range to altitude arc that you get over there to find a vertical speed that's good. Then just dial down the indicated airspeed. And the next easiest thing for us to do is to extend that speed brake. And you will notice this thing is incredibly effective. We are going to start bleeding speed very quickly. At some point on the approach, the glide slope is going to come in, and if you are not using profile mode, which is of course the default if you're flying along a standardized route, but if you're not using profile mode because you're getting radar vectored, it's a good idea to use vertical speed in order to fly yourself into the glide slope so that you can easily control your altitude that way. Alright, now let's say we are getting cleared for the ILS. Let's turn right, heading 190, cleared ILS approach. Like that. And once we're cleared for the ILS, there's two things for us to decide. The first one is, are we close enough to actually use approach mode? So the land button. Today we are, so I'm pressing that mode. You basically only want to use that when you are confirming positive indications for both the localizer and the glide slope. Right, at this point I am going to pause the simulation here, because there's a couple of things for us to discuss for the approach itself. So let's just pause this momentarily here and talk about what we are going to do. Okay, so for the approach, let's talk about a couple of basics before going into the details. Now, speed. Passing 10 miles and you get your DME up here, you want to have the flaps out in flaps 8, and you want to be in 3000 AGL, and you want to be below 200 knots. So you can see we're 11 miles out, speed is 190, however the ground speed is still a little higher, so we want to reduce the speed further momentarily here. And the altitude is looking good, since Geneva is located at an elevation of around 1,400 feet, so we are 3,000 feet above the airfield. You want to intercept the ILS usually with flaps 8, so that you can fly the entire approach down in idle thrust. So, what speeds do we actually want to fly then? This is where things get tricky. So, you got the green dot over here. The green dot is the minimum clean speed. The Fokker flap extension schedule is going to tell you to extend flaps 8 when you're 20 knots above green dot. So green dot 170, once we're passing 190, we want to go flaps 8. Then we can reduce to green dot minus 10. Yes, it is that complicated. It is not telling you the actual flap speeds on the speed indicator. You have to do that yourself. So flaps 8, green dot plus 20. Flaps 15, or rather with flaps 8, you can go down to green dot minus 10. At that point, you've got to go flaps 15, then you go gear down flaps 25, and then eventually down to the landing setting. For flaps 25, you want to fly the amber band plus 5 knots as a minimum, and once you're at the landing setting, just go down to the V approach that's shown down here on the FMS. Sounds a little complicated. It isn't that problematic once you're actually getting the hang of it, but just be aware that these things are, you know, a little different than what you would be used to from your standard Boeing or Airbus aircraft. Now let's go ahead and do that. I'm removing the pause over here, and we are flying ourselves towards the ILS.
Flap 8.
Here you can hear the first officer saying that flaps 8 is available, since we're now at green dot plus 20. So let's go ahead and extend flaps 8. The flap indications shown to you on the primary flight display. And now we are approaching the profile over here. Now let's see how well I timed this. Localizer should come alive any second now. And then we should get a double capture. Here we go. Localizer capture, glide slope capture. Let's go ahead and start reducing our speed to green dot minus 10. So that's 160. Now I just want to show you a little bit about the way that the airplane is flying on the approach. So you can see with flaps 8 and on the glide slope, idle thrust, very slightly losing speed. So that's our preferred setting for flying down an ILS. Now it is going a little left and right here, that will be corrected with an update, don't worry about it. Now our standard approach profile is going to be flaps 8 reducing to green dot minus 10 until 6 DME. At 6 DME we're going to gear down flaps 15, and that's why we really start to reduce our approach speed, so that we meet the stabilized approach criteria in IMC at 1000 feet and VMC at 500 feet. Alright, so here's 6 DME, let's go gear down, then we can also go flaps 15, and we start reducing our speed.
Check flap 25.
And we are reducing our speed further. Green dot minus 10, the first officer tells us that the speed is good for flaps 25, so let's go flaps 25, and then also arm the lift dampers. With that, we can now read the landing checklist. We can warn the cabin at this point of the imminent landing by pressing the all calls button. Okay, like that we're now slowing down. Our cabin is warm, the altimeters are set, missed approach altitude, You would normally set that when intercepting the glide slope. You can see that's 7,000 for our approach over here. So let's go ahead and set 7,000. Okay, the cabin is secured, the missed approach altitude is set, all that lovely stuff is done, and then we are basically ready to fly that final approach. So, to complete the checklist, the landing gear is down, lift dampers armed, flaps set, and that's our landing checklist complete. Alright, let's pause this over here, and let's start talking about the landing. So if nothing further is done, the airplane is going to conduct an automatic landing. However, for the purpose of the tutorial, we do of course want to do a manual landing. Now, let's go ahead and talk about the procedures over here. First of all, passing the stabilized approach gate, which is going to be 1900 AGL for us, we want to be down at the approach speed, and we want to be completely stabilized. What does stabilized mean? We have an appropriate pitch. We're on the glide plus minus 1 dot. We're on the localizer plus minus 1 dot. We have an appropriate speed within plus 10 to minus 5 knots. We have an appropriate vertical speed. Our engine thrust is at an appropriate setting. The landing gear is down and the flaps are in the landing setting. Now, if that condition is not met, simply press the toga button, go around, that's it. Now, when those settings are set, we can continue the approach. You will notice that the Fokker is a pretty pitchy airplane. So when your speed is varying, you will have to correct the pitch pretty intensely. Now, I am using a preview version of this airplane, and that one has a GPWS, which is a little annoying. So if we do get any warnings on approach, kindly disregard them. Don't do that in the real world, just do that at home. And with that, we've discussed the theory. Now, our approach speed is 133 knots over there, so let's go ahead and dial up 133. Like that. That speed buck is going to come up once we take the airplane out of the pause, so we're basically approaching the stabilized approach criteria here. I would recommend always to use manual thrust when you are in manual flight. The reason is that the auto thrust is rather laggy, so it lags behind, it's not flying very precisely. So use manual thrust with manual flight. Now, as briefed earlier, we are doing an auto brake off landing over here because the runway is more than long enough. Remember, with auto brake low, we would need about 1,500 meters. We have much more than that, so we are not going to worry about the auto brake. Instead, what we are going to do here, what is a pretty common technique in the real world as well, is that you just go idle reverse with no auto brake, have the airplane slow down, and when you are below 100 knots, or even slower if you've got a longer distance available, then you would slowly apply manual braking in order to reach the target taxiway. That way you're not blocking the runway for too long, because remember, your airplane is going to slow down much quicker than most aircraft in the environment that you fly in, and you don't want to be blocking the runway for too long. You do want to minimize the time that you spend on the runway. So, for the flare, you just pitch up a degree or two, no more than that. Idle thrust. You can easily go to idle at 50 feet in the Fokker. Flare, touchdown, fly the nose wheel onto the ground, don't let it drop, don't let go of the control column just because the main wheels are down. If that nose wheel crashes down, the guys on the front, which is where the most expensive seat are not going to be happy. So take it nice and easy, put her down, fly her down, and that's it. Alright, let's go out of the pause and have a practical look at the landing here. So I'm going to disconnect the auto thrust. You can see the FMA change there, and the same for the autopilot. Again, you can see the FMA change there. So we're reaching the target approach speed, and you can see how the engines are a little laggy there. It takes a bit of time to stabilize it. Make sure your entire airplane is in trim. Make sure you're on speed within plus 10 to minus 5, though you should avoid getting below the target by most means, because you will find that as soon as you get below the approach speed, the airplane really loses lift quickly. Aim to keep the pitch as constant as possible. When your speed changes, you will need to correct the pitch pretty quickly in the Fokker. So just aim to minimize your inputs, Keep her stabilized. You have to have landing clearance by the time you overfly the threshold. You don't need to worry about the minimum. And then at 50 feet, look to the end of the runway. 30, 20, flare, idle. 10. And then actively fly her down, don't float. And here we are. So,
reverse.
I'm just using idle reverse over here. And you can see with idle reverse and auto brakes off, she's decelerating rather fine. So let's have her decelerate while maintaining the center line. And then we can apply manual brakes in order to reach and exit properly. By 60 knots you have to be in idle reverse or go completely out of reverse. And with 55 knots or less we are allowed to enter the rapid exit taxiways. But do remember, for an exit that is in a 90-degree angle to your runway, you have to be at 10 knots or less. Once your airplane is completely behind the line, so the entire airplane behind that line, that's where you can stop. Do not stop until your entire airplane, that includes the tail, is behind that line. Or in low visibility conditions, that line. We are not on low vis today, so just using that line over here is sufficient. And with that, welcome to Geneva. You can see the plane has a little tendency to float, so do proactively fly down onto the runway. You only need a degree or two in the flare. That's absolutely all you need. Alright, and then let's go into the after landing procedures. So we are vacating the runway, we are clear of the runway, and now there's a couple things for us to do. Again, you do have the checklist down here if you do need help with that. You can use that all the time, but normal airline procedures, you do learn that stuff by heart and then just use the checklist to correct. Okay, so starting up here, lights. We turn the strobe lights off and the landing lights off. Again, if you have a taxi light, use it and turn that one off. If you don't have a taxi light, use the middle light as taxi light. APU as needed. We are going to start it today. You can delay the APU start until you're a little closer to your stand in order to save some fuel. Up to you. Weather radar off, which you do through the weather radar brightness button up here and up here. Then going further down, we are going to set the transponder into XPNDR, retract those flaps, make sure that the lift dampers are in, and then we are going to turn on the control lock. And with that, we have vacated our runway, and we can now taxi our little Fokker to the gate and get parking. So I'm just going to go with some gate that's close by over here. Doesn't really matter which one it is, but I do want to take one that has a jetway today, because that is going to offer us a neat possibility to showcase something. Okay, so I do believe that that one over here does have a jetway. At least I hope that that jetway is for it. So, entering the parking stand, let's go ahead and turn the lights off. Actually, that was a water drainage. That was not a taxiway line. My mistake. Okay, so entering and approaching the stand, make sure that all the taxi and landing lights are switched off, the strobe lights are off, and the weather radar is off. That's just to protect the ground personnel. Anticipate a tight turn by turning early enough, and then use the oversteering as needed to be sure that you get the airplane into position properly with the main wheels on the center line. Like this. You can see the airplane is aligned pretty nicely. The easiest way to make sure you're on the center line is to just make sure that the center line goes through your right butt. Okay, so we're just gonna stop at stop number 1 over here. Gonna do it that way, and here we are. Okay, so set the parking brake. Ensure that the APU is available. You got the blue avail light there, or you can just see APU available down here on the status page. When the APU is connected, the parking brake is set. We are going to shut the fuel levers, and then we are going to set the transponder to standby, the seatbelt signs to off, the beacon light off. The only light that should be on at this time is the nav and logo light. All the other lights should be off. Then we are going to ensure that all the anti-icing is set off. We are going to turn the fuel pumps off. And then we're going to turn the window and probe heats off. Like that. Then we can run the shutdown checklist, and that's it. The APU, after 2 minutes, is automatically going to start turning on the air conditioning. And that's pretty much it. So let's go ahead and see if we can get the jetway over here. No, we cannot. Okay. So I'm gonna have to show you from the cabin itself. Now let's go ahead and unlock the door. So, there's 2 types of doors on your Fokkers. One of them is this one that has the integrated air stair. However, that does not prevent you from using a jetway, but you gotta use a little trick. If you click on the guardrails, you're gonna get to the outside. And on the outside, you can click on the bottom over there. Alternatively, when you're on the inside, you got that little plate on the left here. If you do click on that, you can see the plate is coming down, guarding the air stair itself, and the air stair is folding away its guardrails. That way, you can now attach a jetway to the aircraft. So that's quite a cool feature there in order to connect your jetway and in order to deboard at a position with a gauge if you got an airplane that's fitted with the integrated air stair. The other option, of course, is your standard door where you would simply fold the door to the side, just like you do on your standard Boeing or Airbus aircraft. Now, that's all we need down there to start our deboarding. So, assuming that our airplane is empty, let's go ahead and secure it and go to the hotel. Only a couple of things for us to do for the securing the aircraft procedure, and I'm gonna get you over those real quick. So, the securing procedure includes turning the IRSs off. For that, you gotta lift them up, otherwise you will reach a deadlock. Like here you can see, I can't turn them left unless I actually lift them up. Like that. Then we are going to turn the display units off, and you should consider not completely turning them off, but at least lowering the display unit's brightness, even if you're just in a turnaround, because, well, CRT screens, they do like to wear out if you're running them for too long. So to increase the life of your units, you know, you can always dim them, something like this for a turnaround. Completely up to you what you do there, but you can extend the unit's service life like that. Then we're going to turn all the exterior lights off. We are going to, and only do this once the passengers are off, turn the emergency lights off. Again, you got to lift the switch out for that. And then we can switch our APU off. Again, lift it out, put it off. That's going to kill the AC power from the aircraft, like that. And then finally we are going to switch off the battery. Give it a minute for the APU to completely properly shut down and close that APU service door. That's significantly going to increase the service life and prevent anything that's not supposed to enter the airplane, you know, like birds, insects, that kind of stuff. Going to prevent those from entering your APU intake door. Finally, turn the battery off, and that's it. With that, we have secured the aircraft, and we are now ready to go to the hotel. And guys, that's how you fly a Fokker 70 or a Fokker 100. Thank you very much for flying along. As you can see, not all that difficult of an airplane once you get the hang of it. A little different to Airbus and Boeing, however, then again, also a little similar, especially if you have experience with the A300, because, well, it's the same avionics manufacturer, and that's your favorite Fokker. Thank you very much for watching. Leave your feedback about the tutorial in the comments underneath the video. Let me know if you watched it completely. Thank you very much for spending more than 3 hours listening to me talking. And with that out of the way, thank you very much for watching. Like, comment and subscribe. If you really love what I'm doing on this channel, I would appreciate a small donation through the Buy Me Coffee link in the video description below. And with all of that out of the way, thank you very much for watching. Like, comment and subscribe, and then I'm really looking forward to see you all again on the next one.